Okay, so if it's correct, you can hear me now. We had some technical issues, but we're starting right away. Thank you all for joining us at this live broadcast from the Observatory in Leiden in the Netherlands. This is the third day of the Ars Electronica Festival for Art, Society and Technology. And normally this festival is organized in Linz, Austria, but of course due to the COVID-19 measures, they thought of a new kind of program. So they asked all their partners to organize events in their name. My name is Sanne van Gammeren and I'm the coordinator of the Old Observatory. We organize events, we have exhibitions, and we also have an educational program. So today you are tuning in from our YouTube channel, and we would like to invite you to also give some comments in the comment section or questions if you have any questions for the speakers today. We can also already have a tryout. So today our presentations are going to be on astronomy and on art. And one of the topics of today is how can you send an art piece to the moon, and what would that art piece look like? So for you to comment in the YouTube section, please tell us if you would like to send an art piece to the moon, what would it look like? What does it have people to remind to? So please leave a comment and we will try to get back to this later. So to start this event, I would like to invite one of my colleagues. He's assistant professor at the Leiden Observatory in Leiden. He's also head of the group Astronomy and Society. Please, Pedro, would you like to come forward?
Hey. Thank you, Sana, and good afternoon, everyone, and welcome to our third day of our Ars Electronica Gardens here at Leiden Observatory. And also, for us, it's a pleasure to have to explore the limits of art and science in this festival, and especially in this place. This is the oldest working astronomical observatory in the world. It's more than 250 years old, and we've been exploring and trying to understand how the universe works for centuries. But also, I think it's very important that we cannot forget to look into the future and to try to understand what we can do as astronomers, but also as members of society to understand what is the link between science and society. And that's why we try to organize events for the public, but also events that invite other forms of knowledge to engage with us and to explore the topic of space. The festival that we are organizing this weekend and started on Thursday, and we explored the topic of for example, radio astronomy and the Drake equation photo exhibition that we have at the moment here at the Old Observatory. Yesterday, we also discussed the powers of 10 concept, which is an interesting framework to put all the scientific knowledge that we have in context and perspective and with different scales and different magnitudes. And this weekend we're gonna focus only on the moon and Mars and trying to understand how artists look at these objects that have been super appealing for astronomers for centuries, and also how they explore the intersection between astronomy and society and art. So I would like to welcome the MoonGallery crew, also Professor Bernard Foing from the European Space Agency, that has been helping us drafting and dealing with this idea of exploring art and astronomy together. And this is becoming very important for us. Since July, we started this topic, and I think in the future, we want to really to be a center for art, science, and astronomy. So Bernard, thank you so much for joining us. It's really a pleasure to have you here. Unfortunately, we don't have open doors only tomorrow. We invite everyone to join us tomorrow, but at least we can start today exploring this amazing topic. And thank you for coming, but also for bringing so many colleagues, artists, and astronomers into our Old Observatory. Thank you.
Bravo. Thank you, Pedro and Sana. Thank you for Leiden Observatory Visitor Centers and Leiden University for hosting us here in what I would call the Leiden Observatory spaceship. This is our spaceship where we are traveling to the moon, and we are very pleased to be here with the Euromoon Mars team, a number of present here within the limit, but also worldwide. We have some collaborators. So I would like to give a little introduction to our Euromoon Mars team. And so if I can get the first slide of the presentation. So it's a project that we have started 20 years ago with a federation of space agencies, industries, academia, entrepreneurs, even lunar explorers. We started a group and with a vision for a roadmap for exploring the moon and Mars. And so if I can get the first slide, yeah, good. And based on this group recommendation, we, so actually we see that this group also 10 years ago, we started as a recommendation from this general worldwide group, a special program called Euromoon Mars. It's a program dedicated to train researchers, to train as well young professionals in all areas for preparing ourselves for what will be science, technology, living on the moon and Mars, and also communicating that to the society and the public at large. So you have seen on the first slide, every year we have new members, so we are growing in this spaceship. And you have, I didn't have the room to put all the names, so I put only the first name. So I can get the second slide, which where I discussed the roadmap that we have identified to go and settle on the moon. We started with orbiters, a fleet of orbiters, and actually I was lucky that I was the father of one of them, Smart One, the first of the millennium, but now we have more than 10 orbiters that have been to the moon. Next step, we will build a robotic village, which has started already with some Chinese landers, and now we'll have commercial landers, and we are going to go towards an international human base with human, robots, and also participation even from Earth. So the next slide, you can see how we have already.
The Human Mars program started more than 10 years ago, where in order to support this long-term objective, we organized some program to develop field campaign in the moon and Mars,
demonstrating instrument, learning the architecture of minimal habitat, and also how to live there with people. Now we prepared for the robotic village where we more than 10 years ago, small lander that we would
at the occasion of the Google Lunar Express, we built
competition.
the mock-up
So
of the lunar lander with
engineers
some
and
of the
scientists
lunar
working on instruments we put on board.
and we tested
And I'm
how
happy
you
to
could
report that this lander has landed here. As we have brought it at the end of this spaceship. We tested it in the field, in Eiffel volcanic region, also nearby. We deployed rovers there, a family of rovers, test cooperative robotics. We tested it also with astronauts to see how we are going to have a partnership between human astronauts and instruments. So next slide, you can see that we are organizing also community events. So twice per year, we organize this so-called Human Mars workshop at large. These are taking place at ESTEC, and then we have had for the last 5 months to have a teleconference.
So we even organized a campaign
where we brought this pandemic, but we were able then to organize campaign. We brought our rover to the surface of the moon. You can see it here. And
also built
we have also built
moon base at ESTEC, where I can lock
down
students for a few hours and
young professionals to experience what it is to live on the moon. So you see them communicating with Earth. They have a 3D printer. They can analyze this. So this we do close to ESTEC, but we go also in the field. We had a program, ESA Lab. Last year, where 20 universities provided
with 20 universities where
into
moon habitat was built under ice.
Glacier. So we brought there experiments from Free University of Amsterdam, robots, and we even brought the same lander that is here. We brought it to the top of the glacier. So these are some of the things. We have some of them with us, Amanda, for instance, and a number of the team. Mark can report on that. Yes. We have also set some campaign in extreme places that look like the moon and Mars. That's volcanoes of Iceland. We went into lava tubes. So we went there in 2018, 2019, and next year we'll have a big base, but this will be described by Mark and Charlotte. Next slide shows, in fact, where we are now very busy to so you can continue.
Recently,
Iceland.
Another campaign
higher in space to the top of the
more recently, we have also engaged in a series of campaigns.
You can see the next slideshow where we can see some of habitats
icy
and the
space.
volcano. We explore lava tubes.
We
And
try to
for
reconstruct.
instance, we brought some equipment, drone, microscope, analytics vehicles, and then we organized full-fledged series of campaign. And then you can just show as a slideshow, as a teaser. You can go to the next one, as a teaser of some of the campaign that we want to organize. So thank you very much for hosting us here. And we will have then our next speakers that will describe what we can do with the Euro-Moon-Mars team, also to support this midterm goal of sharing the data, sharing the experience towards the Moon and Mars, but also bringing and having a settlement there. So thank you very much. Back to you, Sana.
Thank you very much, Bernard. So after this introduction to the Euro-Moon-Mars team, I would like to introduce the next speaker. Next speaker is geology student Amanda Kruiver. She's studying at the VU in Amsterdam, and she does research on exoplanets and asteroids. Please, Amanda.
Thank you very much. So we'll start off with a little bit of hard science. I will quickly tell you about some research that I'm involved with, and then also talk you through Euro-Moon-Mars activities. So, oh, 1 second. Technical difficulty. Yes, there we go. So one of the researchers I'm involved with tries to predict surface temperatures on large terrestrial exoplanets by modeling the long-term carbon cycle coupled to a parameterized convection model. So the long-term carbon cycle is able to regulate planetary climates because it's a negative feedback system. So when atmospheric temperatures go up, weathering rates increase, which draw CO2 from the atmosphere, therefore lowering the temperature again. And if we look at the results, which you can see in figure 1, you see temperatures between 286 to 291 kelvins, which translates to approximately 15 degrees Celsius on planet Earth. Plotted against mass. So what you can see is that these temperatures are actually quite stable, quite robust against changes in mass, which has good implications for planetary habitability. So if you look at very large terrestrial exoplanets, temperatures don't change that much. And another research I'm involved with is something completely different, namely the modeling of 3D asteroid structures. I'm waiting on the slide. Don't worry about it. And so what I'm trying to do is, when we have meteorite thin sections, to build 3D structures, model structures out of it. So we take a meteorite thin section, then we translate it to binary data. So we actually separate it in 2 phases. And if you have 2 phases, you can use certain, so-called endpoint polytope functions. And you get several graphs for this. And if you look at figure 3, you see that there are very small waves in this graph, and these local maxima. These you can translate into 3D information structures, because if you have a 2D meteorite thin section, and it doesn't matter in which direction you sample, you can make a 3D structure out of it. So now we're going to a little bit less hard science. A big cornerstone to Euro-Moon-Mars is doing outreach and finding future collaborations. So together with my supervisor Bernard, we went to China. We went to the Changsha Space Conference, where we talked about past, present, and future activities from the ESA, Euro-Moon-Mars. And it was very special to be there, because it was not only a very hard science incentive, but they also talked a lot about philosophy, psychology, because when you go to the moon and have many residents there, how do you prepare for violent clashes? Should you select astronauts on certain personality traits, or would you train astronauts? And if you have already people living there for multiple years, how do you choose who's going to live there next? Will Earth decide this, or will the moon residents take care of this? So you can see us talking over here, very serious business, of course. And this is not only, we visited also, next slide, please. The CAST, which is the Chinese Academy of Space Technologies. And we really had a very intimate round-the-table discussion where these top Chinese space professionals asked multiple questions to Bernard. Where should we land on the moon, or on which asteroids to choose? And it was very beautiful to see this collaboration, because they put a lot of trust in us Europeans. And this is how you can see how science can promote international collaboration. And we ended our trip at the Beijing Institute of Technology, where we held our classical Moon Village workshop, where we asked some students to devise their dream moon village. And what would they bring? What kind of science would they conduct? And it was beautiful to see that many students would want to bring their musical instruments. So yes, I think this is what I would like to say for now. Thank you so much for tuning in, and I give words back to Sanne.
Thank you very much, Amanda. We are going further on program to another student, Iris Schuring, if I was correct, yeah. And she's from the Amsterdam University College, and she's also, she's also doing an internship with Bernard Voing on the Martian climate. Please, Iris, go ahead.
Thank you for the introduction. So I'm Iris Schuring. I am from Amsterdam University College. I am mainly a physics student, but at my university, I also get to combine it with courses in other disciplines, and I like to focus on earth sciences. And so the thing I really like about combining earth sciences and physics is combining it into climate sciences. And this is of course an especially important topic nowadays, but it is also interesting by itself. And it's also interesting to look at other planets and how their atmosphere functions. And so I'll be looking at the Martian climate, and I will be comparing it with extreme climates that we find here on Earth. For example, in Utah, Hawaii, or Iceland, where we have these explorations with our team. And I'm doing this internship with Bernard. I just started, so I don't really have much of a specific research question yet, but something that I found really interesting when I was looking up the things about the Martian climate is that it's actually pretty predictable when we compare it to the Earth climate. We have quite limited data of the Martian weather compared to Earth, of course. And however, what is really noticeable is that weather events happening at a certain time will within a year or so happen again, almost at the specific same location in a very similar time range with about like 1 week or so, which is insane when we think of, for example, like the weather apps that we use in the Netherlands or anywhere else. And we know not to trust them because they're so unpredictable. And so that's something I found really interesting. Also, it's really interesting to look at the role of water on climate, because as we know, we don't really know that much about the water on Mars. And so it's really interesting to see how that influences climate compared to these extreme climates on Earth, where there is water. And so, yeah, that's what I'll be focusing on in my internship for the next oncoming months. And yeah, I hope to get something interesting out of it.
Thank you so much, Iris. For our next presentation, we will tune to Vienna. There we can find our space architect and analog astronaut, Sabrina Kerber. Sabrina, are you here?
Hi, yes, I'm here. Can you hear me?
Please go ahead.
Okay, so I'm going to screen share because I have a presentation for you. All right. All right, so I'm gonna be talking about what I'm doing for EuroMoon Mars as an analog astronaut during the MS2 mission, and also tell you a bit about what I'm doing as communications manager for EuroMoon Mars. So to start with the MS2 mission, which took place in December 2019, so we were really lucky that we still got to go before the pandemic closed everything down. I did various research investigation in the area of space architecture and habitability. I did 2 projects together with another space architect and also one of our crew members, Ariane Vansken, and I'm gonna present them to you now. So what we did first was we did an investigation of semi-privacy. So what we saw, here I'm trying to make this smaller so you can see the presentation. Previous research has found out that in space habitats, as for example in the analog habitat at high seas, that there is no real private space. So if you want to have privacy in the high seas habitat, you have to go to your crew quarter, which is up here. And you have to shut yourself in there. And this can create a really bad situation and bad vibes for the crew in general, because it's not good if 1 or 2 people just leave and shut themselves off. So it would be really helpful if we had a area where we have the possibility to withdraw and have a more private situation while still being able to participate in the general happenings in the habitat. So our research question was more what kind of privacy is necessary for extraterrestrial habitation, as opposed to the question of how much, and this is a question that has been asked a lot, but the question of what kind was really interesting to us. So we created this semi-private area that you can see here, or this one is the floor plan, and you can see we just put up 2 partitioning systems, and this wasn't about creating a great architecture, it was about creating a very, very simple means of having a semi-private area. So we had those 3D printed nodes and a really easy pole system that we could stick together, because of course we also had to bring it to the moon. So for 2 weeks we had this semi-private area, and we did daily surveys with the crew members to see how the private area was received, how much did they use it, and we found that they received it very well. It was really nice to have a space where you can withdraw with other crew members to, for example, watch presentations, even have some music sessions in your free time, but it was also really valuable to have crew discussions in a more private environment, because otherwise you would have to either sit at the work tables here or at the big table here, where you're very open to everybody's eyes and ears. So this was the one investigation that we did about habitability, and the other one was about the influence of color, which is also a really important factor of habitability. So you probably know that color can not only influence our mood, but also has effects on the stress levels, on the spatial perception. So rooms can appear much bigger or much smaller depending on the applied color. And what we did during our mission is that for the first 2 weeks of the mission, we actually eliminated all kinds of color in the habitat. You can see we went out of our way to cover up any colorful surface. So we ended up with a monotonous black and white environment, and we asked the crew to wear only black and white clothing for those first 2 weeks. We removed all of the colorful tools or applications, private objects that were brightly orange. We covered them up. And then after the first half of the mission, we did another round of removing all of the coverings, and we reintroduced the color just for a comparative measure. And we also did surveys each evening, and we saw that the motivation and the mood and in general the productivity really increased in this second half of the mission. And we also got really good feedback about the crew being really, really sick of the black and white environment. And then we were super happy when we allowed them to have some more color in the habitat again. And then the third project that I did was a collaboration with the company MakerBot. They're creating additive manufacturing technology. So for example, 3D printers. And I was allowed to bring a 3D printer to the moon and try how this machine could help us improve the engineering aspects of being on a moon mission, but also the habitability aspects. And of course, there were a couple of challenges. So for example, the high altitude was a problem because in the beginning, the printer didn't work properly until I realized that I had to recalibrate the whole system to make it work in this really high altitude. And of course, this is also something that we have to keep in mind for having a printer on the moon. But in general, once it was working really well. We printed several tools for the engineering side of things. So we did a tool for a rover construction, and we did a part for our mission drone. And this part for the drone, for example, was something that we did not foresee we would need. And then once you're on the moon and you don't have something that you really need, you can't just call the people back home and have them send it in a day. So it's really important that you have some means to quickly solve this problem and to create something like a tool that you need to build something. It's also super good to have a 3D printer because sometimes the tool that you have does not fit the problem, and then you can very quickly adapt the design. As you can see here in the right picture, I'm preparing the print. So I had software with me that allowed me to adapt the designs and then print it, so we could really quickly adapt to current needs. And it's pretty much the same for the habitability side of things. So being able to 3D print personal items or leisure time objects, so pretty much fun objects that you wouldn't think are that important, actually turned out to be really important. It was a super good support for crew bonding and also really important for breaking the monotony. And I would say especially for long duration missions, it's really important that you are able to print new leisure time objects because after a couple of months, it will get really boring with the 5 objects that you were able to bring. So overall, it was really a successful project, and I highly enjoyed the EMIS mission. So I can really recommend it to anyone who's interested in doing that. And to finish off my presentation, I am also the Euromoon Mars Communication Manager. And so for me, this means doing digital outreach like social media, but also creating graphic, for example, graphic material like flyers. I'm co-organizing and co-moderating live web shows on the Euromoon Mars YouTube channel, co-organizing events. We have a cool habitat workshop happening next week in Vienna. So hopefully if the COVID situation will allow it. We have weekly communications meetings with the whole communications team. And it's just in general really staying up to date with our projects and also making people aware of how it's possible to connect with us. So if you want to connect with Euromoon Mars, you can either follow us on social media or just email us in general, but it's very easy to just follow us on our social media channels. And that's it from my side. Thank you so much for having me.
Thank you, Sabrina. Thank you so much for your nice talk. It was very interesting. Oh, of course, that's for you. Thank you. So from Vienna, we are now tuning into Hawaii, and I want to give the floor to a director of High Seas, Michaela Musilova. Thank you.
Hi everyone, this is Michaela Musilova. I'm greeting you from the moon, or analog moon anyway. I'm currently on a simulated mission to the moon at the High Seas Research Facility in Hawaii. It is the station you can see on the image here, located on the volcano Mauna Loa at approximately 2,500 meters in altitude. The station High Seas was originally built for missions in collaboration with NASA and the University of Hawaii. They were long-duration missions focusing mostly on human psychology. For the past 2 years, the International Moon Base Alliance has been organizing various missions, enabling the HI-SEAS facility to be opened up to other organizations, not just NASA and the University of Hawaii. We have been collaborating with the European Space Agency, a number of universities around the world, and even separate groups of people, for example, the Sensoria missions that are organizing all-female crews. And in this way, wanted to open up this facility for other organizations and people who want to contribute to space research, and they can do both analog Moon and Mars missions at HI-SEAS. This is what the inside of the station looks like. It's a dome with a diameter of about 12 meters. There's very little privacy in there, even though every crew member gets a small room of their own, as you can see in the top right picture. The rest of the space, apart the bathrooms, is a common working area where you do everything from cooking, exercising, working, and various types of group activities and research projects. This is an example of the kind of freeze-dried food we have to eat on mission. Everything is either in the form of these freeze-dried granules or powder, so the crew has to be inventive to make this food be enjoyable to eat, and also they have to take care to make sure that the food will last for the duration of the mission, so they don't run out of any supplies, because they do not get resupplies on short duration missions such as moon missions for 2 weeks. They also have a limited supply of water during the mission, so they have to be able to control their usage. They're usually allowed only a minute of shower time per day, so say 7 minutes per week. They also monitor how much they drink on some mission depending on their research projects, and they have water sensors to monitor their water levels. Again, they have to be able to survive with the amount of water they're given for the duration of the mission. Everything that goes on the station is monitored from a mission control center, also located in Hawaii, and the crew is provided with remote support from all around the world, including various volunteers at ESA ESTEC and other ILBEC members, and so on, depending on the mission type. You can see the mission control center can see how for example, the temperature is like in the habitat, how much power they have left, how their water supply is doing, and thus give them guidance like a mission control center during real space missions on what they should watch out for, what they should do, and if they need help, they give them provide them support virtually. And if it's a moon mission, there's only about a 3-second delay. With Mars missions, we're talking much longer delay, sometimes up to 20 minutes each way. And if we were to do even longer duration missions beyond Mars, then the delays would get greater each time. And these delays in communication mean that the crew members cannot have a live conversation with anyone. It also makes them have to be more independent. In case of any problems, they are completely reliant on themselves. Remote support can only provide them guidance and advice, but they have to troubleshoot and actually resolve the problems on site alone. Of course, in medical emergency, the simulation would be broken so that the crew members will be provided with the help they need, though there's always at least one medically trained personnel in the crew, and there's an on-call doctor that can help from everything from minor problems to more severe ones, all the way to managing emergency situations and calling emergency response services. Here are different types of examples of the research that are research projects that are performed at the HI-SEAS station during the different types of analog missions. Some of it is to do with geology and mapping, for instance, of the different lava fields that are present around the habitat. Because the station is located on a volcano, it is surrounded primarily by different lava flows. You can also find interesting lava tube features. Many of them have been mapped, but there are still a few that need to be mapped in more detail, and that is the subject of a lot of research during the analog missions. You can see some examples of the mapping and data collection from some of the recent missions. Other research projects focus on geochemical sampling and astrobiological studies at HI-SEAS, going into lava tubes, as you can see in this picture. and collecting different types of chemical, geochemical, and potentially biochemical samples for astrobiology research. Lava tubes are also studied as a form of potential analog habitats. As you can see from the picture on the bottom right, people could actually fit into some of these very big lava tubes very easily. So these lava tube systems are being mapped and potential habitat structures are being designed to fit inside of them. Different types of research also touch upon the physiological, psychological, and sociological research of crew members during the mission. You can see different examples in these images. In the images on the left, the crew members are wearing we call them emotion sweaters, but these are devices that detect the mood of the different crew members, and they're used for team bonding activities and to increase empathy between crew members. Other research focuses just on the influence of regular exercise on the mood of the crew members and their general well-being, and you can see some examples of that in the pictures on the right. We also do a lot of different types of technology testing, especially things related to in-situ resource utilization, but we also have access to different types of rovers and drones, as you can see in this image. Some of them are in collaboration with organizations directly here in Hawaii. For instance, the organization Pisces, which lent us the big rover you can see in the image on the top left. And since we have to do so much engineering work, we have at least one designated crew member that's an engineer, and they have to maintain all of these different systems and equipment, write daily reports, and troubleshoot any problems with the help of mission control. The different missions at high seas, including the MS missions, which are the Euro Moon Mars, IMA, International Moon-Based Alliance, and high seas missions. They are involved with many educational and outreach projects. Here are some examples. In the bottom right picture, you can see me with a research project designed by high school students in Slovakia, which was focused on using human hair as fertilizer to grow crops on future space missions. And then various types of documentary films were filmed here, including a recent film called Space Drop, trying to make people understand the importance of space exploration and how it might be relevant to all of us on Earth one day. And finally, all of the research data and findings from the missions at high seas are being gathered to build a prototype moon base here in Hawaii in preparation for the building of a real moon base on the moon one day, which we are hoping will be an international collaboration and an interdisciplinary one, which is why we encourage a variety of types of research projects to take place at high seas. We would like to acknowledge all the many crew members of the different missions that took part at high seas. There are too many to put on these slides, but as a big general thank you to all of them for everything they have done for this facility and for research, space research in general. Here are some references for more information about some of the research projects that we've been doing at high seas. And if you would like any more information, here are my contact details and some social media information where I post also recent pictures and reports from missions, including the one that I'm currently on right now. So thank you very much for your attention, and greetings from the moon. Aloha.
Thank you, Michaela. Now we're going to the next speaker, and this is going to be space engineer Ana Castron. She is from Brazil, and she studied in China. She did a master in space law, and she has been part of MS2 missions for high seas. Now I'd like to tune in for her, so give her some applause in advance, please. Thank you very much. Go ahead.
In person, joining the meeting with you guys, but unfortunately because of travel restrictions, I can't. So I'm just going to present briefly about engineering and a moon-based analog, my perspective being an analog astronaut doing MS2. Just briefly about me. My full name is Dana Paula Castro de Paula Nunes, quite a full name. I'm originally from Brazil. I hold a bachelor's degree in aerospace engineering. Just finished my master's degree in space law and policy. And I got in touch with MS during my summer internship at UNOSA, the United Nations Office for Outer Space Affairs, where I met Sabrina and Bernard, and then I joined AMIS2 as chief engineer. And I believe I'm the first Latin American to participate on an AMIS mission. So, yeah. AMIS2 was composed mainly by women, and of course with our dear Joseph D'Angelo. He was a chief medical doctor. Michaela was the mission commander. I was the crew engineer. And we had also Charlotte, that you know, Sabrina, Ariane. And it happened in December of 2019 for 2 weeks in Hawaii. So about the engineering on the analog space mission, I'll talk about briefly the role of an engineer, what tasks and responsibilities, and the challenges and outcomes. So one of the main parts of being an engineer is that you have to be creative and you have to solve problems at all times. But during an analog mission, you also have to undergo all the procedures and daily tasks they do. So it's a lot of work to do, even though you don't have your own side project, but it's a lot of work to do, and you never get bored, trust me. And here's an example of us using toilet paper to try to find the leak on the water tank during an EVA. The task and responsibilities then. A chief engineer or an engineer would take care of the habitat, equipment, power system, solar panels, ensuring nominal operations of the EVA, which is the extravehicular activity, and all the equipment before and after getting feedback. We also have to do daily engineering reports where we write everything that happened during the day, how the equipment is working, recommendation for improvements, if there's any troubleshooting needed, and of course, requests from mission control and remote support. As I said, we have to do this daily engineering report, which takes a long time to do. During MS2, I also operated drone and rover. The drone we bought and assembled there. And also when you have time, you can support other crew members' projects. Here's our small rover. It was very complicated because many things happened wrong. So in MS2, we barely have time to test it, but it was controlled remotely in the Netherlands while we were in Hawaii. The drone was also very useful. We got some really amazing images with it inside and out of the habitat, and it's a small drone, but it's a powerful one. So we named it a special name. We call it Special, and it was very useful. And during MS2, we also had to do engineering UVAs only to fix stuff outside the hab, and it took a lot of time, and it was very exhausting as well. So what are the challenges and outcomes? As I said, the daily schedule there, even though we're on the moon, we also try to follow with the day on Earth. So we had a little bit of time every day for free time. So if there are any problems and everything was very worrisome. So, but the crew was awesome. Everyone was helping each other. Another thing, of course, like any space mission, it is limited communication window, time delay response, and troubleshooting. We can only communicate with mission control and remote support. Only open communications through a specific time window. So if anything is urgent, you kind of have to deal with it on your own. And for the moon, we had a time delay of a few minutes, but if it was on Mars, it would be like nearly half an hour. And to troubleshoot without any further support is also very, very hard. And after the mission, I gave mission control some feedback on what we could improve on the habitat itself, but also in regards to the mission. For example, we believe that at least 2 crew engineers per team will be very useful, so they can rotate tasks. And of course, to test and check all instruments and everything, be familiar with the equipment, and do some drills for emergencies was very useful as well. And that's it. Okay. I hope you enjoyed it. And if you have any questions, feel free to ask Bernard, or you can also reach out to me by email. Okay, bye.
Thank you, Anna. Thank you for your great talk. Thank you. Next, we are going to geology student Anna Lotteweers, and she's from the VU Amsterdam, and she has been in MS1 mission And she's also from High Seas. So please go ahead.
Thank you. So yeah, I'm going to tell you something about the preliminary results of the first Euromoon Mars IMA High Seas 1 mission, which took place in February and March 2019. So it's already 1.5 years ago. And therefore, I'd like to introduce to you the crew. Oh. No. Oh yeah, there it goes. So here we have a picture of the crew. We had the commander, which is Michaela. She's on the most right girl with blonde hair. Next to Michaela on the right is Sebastian. He was like me, a geologist and geochemist, and together we did scientific research about the rocks around high seas habitat. Then right to Sebastian, there's Niti. She is a system engineer at ESA, and she fixed everything that we broke. So yeah, then there's me, and next to me there's Josh. He is an American journalist, and he made the space drop documentary Michaela already told you about. And then we have Benjamin. He wrote some articles and did anthropology research about how we felt during the mission. Then I'm going to tell you something about the research project. We were studying the rocks around the high seas habitat, which are like 95%. They have the same chemical composition as the rocks that we can find on Mars. So we can use the rocks that we can find on Hawaii to compare with rocks from Mars to see if we can find some similar or different processes that can form the rocks as we see them today. Sebastian's research was about microbial life in lava tubes. Lava tubes are like big tunnels underneath rocks, and we can find them on Earth, but also on the Moon, and as we can see on the right picture, also on Mars. They host stable conditions for life, as you are protected against sunlight, radiation, and heavy weather conditions. And these type of microbial life, when they are present, they can leave secondary minerals, which we can see and study. And he did some research on that. And I did some research on the Hydrous alteration of different lava flows. Why should we know something about that? Well, if you have Hydrous alteration, clays can form, and this can only happen if there is water present, or Hydrous clays only form when there's water present. And this can tell us something about the aqueous history of a rock. So if we can learn something about this history of the rocks on Hawaii, we can also learn something about how there was water on Mars. And as we know, water is important for life to be there. So if we know something about water, we maybe can say something about life on other planets. So first I will show you some of the results of Sebastian's research. We found 3 types of secondary minerals formed by microbes inside the lava caves. The first ones were like white powders. We called them space cocaine because it was a really typical white powder. But this space cocaine was made of ternadite and metabolite, which are 2 different types of minerals. Second, we find crystalline crust on top of the rocks, which were made of gypsum. And we found coralloid speleotherms, which are like coral structures, but then on rocks, which are not inside the ocean. And if we look at these coralloid structures underneath an scanning electron microscope, we can see some growth structures, just like a coral inside the sea. So how does this type of minerals form? If you have a lava cave, meteoric water which falls on top of the rock precipitates through the rock, and while doing that, it takes up some elements inside the water, which can form these type of secondary minerals when the water leaves the rock and comes inside of the cave, and for instance falls on the floor or leaves a layer on top of the cave's roof. How can we compare these type of results with Mars as an analog? Well, the white powder we found on Hawaii maybe was found on Mars too, but we do not know. We only have the picture at the bottom where you can see a white powder inside the red circle. We do not really have measurements from it, but it seems to look a bit similar to the powders we found on Mars. Also, the spectra, which Sebastian found, are a little bit the same as we can find on Mars. So maybe there are the same type of secondary minerals that microbes form on Hawaii found on Mars as well, but we are not sure, of course. Then I will tell you something about my own project. I looked at the alteration of the lava flows, as I already told you. On the most left picture, you can see one of the youngest lava flows I studied. You can see a really shiny layer on top, which is disappeared in the middle picture of a lava flow, which is about 300 years older. This is due to, or the removal of this shiny layer is due to the acid rain on Earth. And if we look to an even older lava flow, we can see that the black top is disappeared and has made place for a brown layer, which increases the depth of this brown layer increases if we go to even older rocks, as you can see in this picture. In the top, you can see the rock samples. I made scans of them, and in the bottom you can see infrared measurements of the same rocks, where the blue dots represent hydrous clays. So you can see as the rock goes older, the top layer of hydrated minerals becomes thicker. So how can we use this as a Martian analog? Well, if we plot the rocks I found at Hawaii in a ternary diagram, we can pretend or see the expected weathering trends of these rocks, which are indicated by the black arrows. If we then put data from Mars in the same diagram, we can see that they do not follow the expected Hawaiian weathering trends, and this is possibly due to the fact that the environment on Mars is way more acid. So the minerals, they alterate in a different way, but we do find the same type of clay minerals as we find on Earth, that we can see in this picture from spectra of minerals I found on Hawaii. Well, if you want to learn more about the first Euromoon-Mars mission at high seas, you can check out Space Drop documentary at www.spacedrop.org. Okay.
Thank you, Annelotte. Please, an applause. Thank you very much. So our next speaker is going to be Charlotte Pauwels. She is a solar panel test engineer at Airbus, and she's also a physicist focusing on cosmic radiation and for Mars, actually. And if that's not enough, she's also an analog astronaut for the MS2 mission. Please, Charlotte.
Thank you, Sanne. So today I'm going to give a presentation about the mission that we're going to have next year in Iceland. I'm going to give this presentation with my colleague Mark, so I hope he is in the Zoom meeting now as well to join in for a piece later on. Yeah, so he probably will be on the moon. He's currently driving to Germany, I think. So we're going to talk about the mission next year we're going to have in Iceland and why Iceland. So Iceland, the geological aspect of Iceland is insane. It looks practically like how the moon and how Mars will have their own systems and how lava tubes will be present there. So we are going to focus on how to build a habitat inside a lava tube in just over 8 hours. I'm just gonna quickly back. Can you tap the, thank you. Yes, so we have a whole big team. So this team originated from the EuroMoon Mars team, which is giving the presentations today. However, the Chill Ice core team is a little bit more smaller because it's a derivative of the team itself. So we have Bernard Voing. You've met him all in the beginning of our presentation. He's our mission advisor. Thank you very much, Bernard. And the director of ILWEG and a coordinator with ESA. So we have Mark. He's currently in a Zoom meeting and he will talk a little bit later. He's our subsurface operations and he's an exogeologist. And then you have me. I'm Charlotte. Hi, nice to meet you all. I'm the head of logistics. I'm a physicist and a test engineer and also an analog astronaut for the MS2 missions, just like Sabrina and Anna and Michaela. Then you have Sabrina, our communications officer. She's also a space architect and she's helping with designing for this mission for the habitat and to construct everything appropriate for what we would need to have on the moon or on Mars. Then we have Evelyn. Evelyn is from Ireland. She was an intern for Bernard at ESA. And she's also our subsurface or surface operations for antenna and radio systems because the astronauts during their analog mission have to communicate with mission control and remote control. And then we have Tom. Tom is from IPSA. He's an aerospace engineer currently doing his bachelor's, and he's a support engineer. So what I would like to point out is that no matter what age you are, you can always join a space team or join these missions. It doesn't matter if you're still an undergraduate, a master's student, a PhD, or you have already been in a career for 40 years. Yes, and then last but not least, we have Robert Heemskerk. He's the brother of Mark, and he is our remote support during these missions. He helps a lot with robotics and assisting us on the political level. Yes, then you see a picture of our team. So we had a scouting mission last summer, actually, to Iceland, where we were scouting and observing the lava tube that we're taking into consideration for this mission. We will talk a little bit about the location of the lava tube and why we chose this lava tube explicit. Yes, can you go to the next? So because we chose Iceland and Iceland doesn't have a big space sector at the moment, we're also helping and developing the space sector in Iceland itself. And how we do that is by talking to the parliament in Iceland, talking to different space industries there, talking to different companies and how their research and their products can be involved in our mission. So you see here we were at a large team with a large group. So Chill Ice mission mainly has constructing an analog habitat in simulation. And how we do that is 2 analog astronauts are being dropped, or maybe 3, depending on how much analog astronauts we have available at the moment. They will be dropped near the lava tube and they will have 8 hours to go inside the lava tube with their own navigation system and build the habitat inside that lava tube. After 8 hours, after they have successfully completed building the habitat, they will communicate back to mission control like, hey, Houston, we are here. And we do this to prepare humans for future analog astronaut missions. And explicitly to train analog astronauts also to go inside lava tubes, because that spot will be the most likely to go to seek for protection in the first 8 hours after landing. So why do we do these simulations? As I said before, analog missions are very important for NASA, for ESA, and for other space companies that want to set up a base inside a lava tube or on the moon or on Mars. Because these analog astronaut missions, they give a proper insight in how it will be and what analog astronauts can expect while being on the mission. So we're also testing the performance of new instruments, testing them in different hard environments like cold areas, hot areas, and how they would react to different communication problems, just like some we have experienced here. We're applying effects to the human body, similar to living and working outside the Earth. Like you will have some sleep delay, you will have problems sleeping, you will have problems with your water, you will have problems with eating and with your food and with your dietary. And all these problems have to be taken into consideration, because they give some effect on your mental state. And we try to discover all the early problems that are being located. And with that problems, we try to solve them before we go to space. So this is really a crucial part for space exploration. And that's where we're focusing on right now. Yes, so here you see a picture of that was taken on a lava tube in high seas that Michaela told us about a few minutes ago. And then why we go subsurface, for this I will turn to Mark, as he is our geologist. So Mark, could you please turn in as well?
Yes, thank you very much, Charlotte. Can you hear me all right? I hope that's a yes. So I will explain a little bit about why we are going subsurface, and it mainly has to do with the transportation. So the transportation is needed for the protection of the humans and any other living organisms that you can find on the surface of the moon, hopefully very, very soon. So you need the protection from, amongst others, the radiation, but you also need an insulation to keep you safe against a high thermal profile that you can find on the moon. So on the moon, for example, it goes down to minus 200 degrees in the lunar night and up to almost 180 degrees Celsius in the lunar day. And especially for lighter metallic alloys, that can be that can cause a lot of stress over time. And then you also need to protect yourself from the regolith. The regolith is the very fine-grained dust that you can find on the moon and Mars, and it can harm any astronaut by getting it into the lungs, and it's carcinogenic. So you really don't want to keep yourself separated from the regolith. And you also have the problems of micrometeorites. So these are tiny specks of dust traveling with extremely high speeds, which will eventually also penetrate through bases or through the suits of the astronauts. And the longer you are on the surface, the higher the chance is that you will get struck by one of those. And lastly, and especially as a scientist myself, I think this is one of the most important aspects as well. You want to be there for the research. It's such a pristine environment. Ever since they were formed nearly 4 billion years ago, they have remained the same. They have not been touched by any sunlight. They have not been altered by meteorites. There was no water, no atmosphere, nothing. So you can really see what the environmental conditions were all those years back. And for this, you of course also need a structure to keep all the astronauts safe, like I said. So in terms of safety, in terms of readiness, and in terms of research opportunities, it is nearly crucial that we are actually going into subsurface. Can you go to the next slide, please? Yes, and here you can see a small skylight on the Mare Imbrium. So the lava tubes, I've been talking quite a lot already about lava tubes, and they're a personal favorite, but what are lava tubes? So I will very briefly explain. Lava tubes, they form when you have a very liquid-like lava flow, which is flowing over the surface of, for example, the moon, Mars, or the Earth. And it has a very high temperature. And the outside, of course, is very cold, so it cools off and it will start to form a solid crust on top. And because it is so warm, there will also be some small vesicles inside. There will be small holes. The rock will be very porous. And this will keep it isolated, so you will remain very cold on the outside. The hot lava on the inside will continue flowing. It's a bit noisy here. So this will eventually form a shell, and the lava will continue to flow through that shell, which you can see in the next pictures. And the outer shell will keep the lava inside warm. It will flow on, and it will eventually dissipate. And of course, over the time, it will also cool off, and then you will have this hollow tube. And then eventually, you can live inside those hollow tubes. And one of the important aspects why we are going to Iceland is another little geology lesson, and it has to do with the origin of the moon and the origin of the Earth and the alteration of the Earth. So on Earth, you have the heavier and the lighter elements, which I depicted here as red and green. And about 4.5 billion years back, they were intermingled and intermixed until you had a very big impactor called Playa that struck the Earth. And eventually the Earth got a little ring around it, which only lasted for a very short while. The ring clotted together and eventually formed the moon. And due to the higher gravity and other geological processes like plate tectonics and subduction, the mantle and the core eventually started to differentiate. And the heavier elements, which are depicted in red here, started to sink down into the core. And that you can also still be seen in the core of the Earth, where we have a lot of iron, a lot of nickel, whereas the mantle is a little bit more silica rich. And eventually, what we can see nowadays is that you have the somewhat lighter material in the mantle. You have a very enriched crust, which is yellow in this diagram. And you have the differentiated core, which is red. And the moon, because it has a lower gravity and because there were no active volcanics or plate tectonics, it didn't differentiate that much. So if you want to have a composition similar to what you can find on the moon, you would like to have the red stuff and the green stuff, but you don't want the yellow stuff. And that's why we are going to Iceland, because Iceland is located on the mid-oceanic ridge where the oceanic plates are spreading and the mantle material is coming up. So the image on the left bottom here is actually the green material coming up. And Iceland is relatively young, which means it doesn't have any continental crust, so the yellow stuff is completely absent. And another funny thing in Iceland is that you have a hotspot. So this is also called a mantle plume, and it originates all the way from the bottom of the mantle with the boundary of the core. And then the material starts flowing up, and some of the core material is actually also taking up, making it very enriched in the heavy elements. So in Iceland, you have the nice red and green mixture, which is similar to the moon and to Mars. So the specific lava tube that we are going into is called Stephanshellir. It's located in the western part of Iceland. You can see a map here made by G.R. Reif. And the lava tube habitat will be located in the easternmost gallery, so the little rightmost point. And you can also see in the profile, it really is a large gallery. It's nearly 65 meters long. It's about 12 to 15 meters wide and over 5 meters tall for the largest part, making it large enough that you can actually construct a habitat inside. And the next, this is a picture where we will be building our habitat. So this picture is taken towards the west, standing at about 45 meters on the inside of the cave. You can see a little pile of rubble there, and our habitat will be located between where this picture is taken and that pile of rubble that you see in the forefront of the picture. So more pictures for the impression. On the left, you can see an aerial photograph made by a member of parliament. You can see on the center of the picture, just a little bit towards the upper part, a series of black dots. And those black dots are the entrances into the lava tube. And this picture is also taken towards the west. So the foremost black dot is where we are entering the lava tube. And on the right, you can see how that looks like. It is a pretty big hole, and the entrance into the tube is somewhat loose blocks. But it is steady enough that you can actually safely descend in there. And as you can also see, there's some ice here. And this is another picture taken from the inside. And we actually, the ice can be a problem for us next year when we are going back in May. But it might also be a very cool research opportunity again. Especially if we were also be able to find ice in the lava tubes on the moon and Mars. With ice, of course, you can water your astronauts, you can water your plants, but you can also make oxygen and you can make hydrogen as fuel for your rockets. So we really hope to find some ice in there as well. So the objectives as the mission, I think Charlotte already told you about most of it. So the overall goal is to discover suitable lava tubes and to see how you can make an estimation of whether they are suitable for settlements and for habitats from a distance without having to go in there. And for the Chill Ice mission, we are planning to build a habitat and to test this feasibility of habitat option inside the lava tube. And we will give our astronauts only 8 hours of oxygen, a bit similar to what the Apollo astronauts had. And they will be limited in their field of motion. They will be limited in their field of view because they are wearing an astronaut suit, as you can see here on the picture on the right as well. Just to make it more accurate to what we would actually do on the moon. So the overall goal of our mission is to build a lava tube habitat in or under 8 hours. So to give a very brief timeline of what we have done so far. So we were in Iceland and we scouted 5 different lava tubes. And you can see some picture here on the left, standing very close to Stephanshellir. We also went on the glacier in Igluna to see what kind of instruments, what kind of research we would like to do. Earlier this year in June, we went back to Stefanssettler. And of course, next year we will do the eventual Chill Ice mission. I think we can skip this slide and the next one as well. There are just some pictures and some overview. And I think this is a bit more important. So this is what we are going to be doing next year in May. So we have defined several phases. So we will have some preparation. We will actually lengthen this. It will be 3 days of preparation on site, where we will, amongst other things, dig out the ice and make sure that there's a safe entrance for astronauts. In the same meantime, we will also train our analog astronauts. And then in phase 2 and 3, we will focus on the astronauts building the habitat. We will, of course, keep in a close watch to make sure everything stays safe. But they cannot communicate with us unless there's medical emergency. Eventually, we will have a wrap-up and, of course, outreach publications. And if everything goes well, and assuming it does, we will continue to build a more permanent space analog habitat in lava tubes in Iceland. So very briefly, we will focus on the exploration. We will, of course, also discover new technologies and help increase these technological advancements. And by that, we will focus on the human well-being, both the humans going to living on the Moon and Mars, but also, of course, for the humans on Earth, in order to prepare for settlements so that we later on can actually colonize the whole solar system, Moon, Mars, and beyond. So with that, I would like to conclude our presentation with our slogan of Chill Ice. You can see some nice glaciers here. We will go from into the Earth to into the universe. Thank you very much.
Thank you, Mark and Nancy, for this nice presentation. Thank you. Some applause, please. Okay, next up is going to be Nancy Vermeulen, and she's the director of the Astronaut Training Center. Nancy, please take the floor.
Hello, good afternoon. My name is Nancy Vermeulen, and I'm a private astronaut trainer and also the founder of the Space Training Academy. I studied astrophysics, worked as a scientist, and spent a large part of my career so far as a commercial airline pilot and professional flight instructor. Now, my lifelong passion for space and astronomy brought me into personal contact with some pioneers of the new space industry, which led to the idea of starting a training program for private astronauts. So, yeah, first of all, what is a private astronaut? Well, that is an astronaut or spaceflight participant which performs non-technical duties for short to medium-term stays in space. He or she will self-sponsor the trip to space or got hired by a private company to perform research or experiments. Well, till now, there are no standard training requirements for these private astronauts, and that's why we started working at a program that covers both physical and mental preparation on a convenient level for that private astronaut. And yeah, imagine that you get a once-in-a-lifetime opportunity to see this picture and for real. You want to be optimally prepared, and that's why we are working so much on the experience level. Because if you simulate this high steep acceleration and decelerations and got also the mental preparation, if you do it for real, your mind will be much more open to enjoy the real experience. And so the Space Training Academy will train future private astronauts so they are well prepared as being space ambassadors, also contribute to meaningful and independent scientific research, and help to increase public awareness at the public at large, because yeah, we want to bring the universe closer to people and vice versa, because we believe that space matters to all of us. So private astronaut training is what we do, but also modular space training for those who are not yet ready to buy a private ticket or get the opportunity. They will taste about the training by just joining in for a couple of individual modular space training. So the training is made up of different models which are interchangeable and discussed with you in person. And the package Private Astronaut will conclude everything. So we start with the Space Introduction Day for those who are not familiar with space. It's a crash course in space and astronomy. And also, we talk about Mars and Mars exploration. Not that private astronauts on short term will go to Mars. That will be for professional astronauts. But we want to give private astronauts a full picture and at least to have a general idea what to expect during their lifetime. The space simulations are quite interesting experiences and are hand-on experiences, which is followed by zero gravity flight. And for the real diehards, we go into a military simulator where we go up to 5-6 G to see how you resist high G. And as well, we put you in a high altitude training where we simulate rapid decompression and oxygen deprivation in a hyperbaric room. So during one of the simulations, we will give you a real experience of acceleration combined with visual experiences. So you will be launched to the moon on top of a Saturn V rocket, which is on itself very spectacular. You will also learn to dock with the International Space Station. Not that the spaceflight participant will do it for real, but if you can do it yourself, you will not be afraid in real life. The more you can do and experience hands-on yourself, if you do it for real, you will have more confidence, you will be less anxious, and so on. We also let the participants give the experience of landing a spacecraft themselves. And last but not least, we simulate a full commercial profile with very nice visuals, which is actually the closest real-time experience to the real thing. But if you wonder right now if you can handle these steep accelerations, well, my first student was my mom. She's in her 70s and she's still alive and doing very well. So I think almost everyone can handle this. Then, and this will be the first project together with Euromoon Mars, we will organize zero gravity flight. For this, we work together with Delft University of Technology. We hire a Citation 2, very small business jets, where we do 7 to 10 parabolic maneuvers, during which we are weightlessness between 10 and 15 seconds. And then, you will learn how to adapt, how to perform experiments, and so on. So a lot of people dream about becoming an astronaut, and I think the next 10 to 20 years, we will see more opportunities coming up, not only for professional astronauts, but also for research and private astronauts. And that's why we will start implementing this space training program for students worldwide. Thank you for your attention.
Thank you, Nancy. Yeah, so Bernard says, who wants to fly with Nancy? That sounds amazing. I think it would be great to be in such a program. Thank you very much. Now I would like to go to the next speaker, and it's project manager at Analog Astronaut Training Center, Agata Kolodzik. Please go ahead.
Good morning. Hello. Very nice to meet you. I'm very happy to present you my 5-minute talk about the habitat in Poland. Actually, I was lucky because I managed to organize 3 habitats in Poland, 3 bases for simulation of analog missions, both lunar and Martian analog missions. Me personally, I'm interested in time perception, in biological clock functionality, in artificial light conditions, like you can meet in spaceships or in future habitats, I guess, on the moon or on Mars. So what we are doing, we designed a special lighting system. This special lighting system simulates the sun, which is much better than now. We have lighting on the International Space Station, and this is what we do in our habitats in Poland. Our habitats In fact, there are big chronobiological chambers for studies on humans. So it means that we are particularly focused on analysis of circadian rhythms in this environment. And we try to provide very sharp laboratory conditions. And this means that the humidity is the constant value, temperature, and of course we know everything about lighting, which is inside the habitat. We can modulate the spectrum, so we have a special channels like infrared channels, UVA light channels, UVB light channels. We have, of course, white light and more reddish, more gold light. So all these fluctuations we can use, we can manipulate, and we can observe reactions in human body. This is very interesting for us. But this is not only what we do here in this environment. Beside circadian rhythms that we analyze here, we also try to simulate other things. So once people are here with us, we try to teach them, to train them. And that is why we are named Analog Astronaut Training Center, because we are also focused on education. So we try to show to our analog astronauts how to perform experiments analogous to these which are performed on International Space Station. We are a private company, but because we are also scientists, we try to find collaborations between universities or research centers. We apply for grants, obtain these grants. So we also try to support all candidates, all of you who would like to participate in a scientific mission here. And for us, the most important thing is that we treat analog simulations not as a game, but as a training. This is one thing. And second thing, as a real research. So we really want to support all studies, all work and human effort in order to send humans into deep space. This is our vision, why we are doing this, and we really believe in this. We love to do this, and we invite you. So I hope we will meet soon here, and thank you for your attention.
Thank you very much, Agatha. Oh, Bernard says see you in October. So next up, next speaker is going to be Michael Waltemate. He is a theologian a researcher from the Ruhr University of Bochum. That's in Germany, and it's for space and religion. So please, Michael, go ahead.
Thank you. All right, so I have to hold that and stand here. Okay, so we've heard it said that interdisciplinary research is welcome at all these analog mission centers and research institutions, and I'm going to talk about that for a couple of minutes because I'm going to be part of the MPOL mission that goes to Agatha's center in October, so we'll see her there. And I'm interested in the and the slides don't change, maybe. Can you do it from there? Oh, I'll just talk over it. Okay, excellent. I'm interested in the human aspects of space exploration. So this, for instance, is a picture of the cupola model on the International Space Station, and habitat architecture is vital for the ways humans perceive space exploration and for the ways mission profiles are being perceived or are being fitted to humans. So you can, when you think about habitats, you can choose certain aspects of habitat architecture that enable humans to do certain things and restrict them to do certain things. You can design your mission as a bunker style mission, as this architecture shows, or you can rebuild human architecture on Earth to enable humans to basically experience the same thing. Something similar is crew composition, and we've had that discussion in space exploration over the last, well, over all of human space exploration. Obviously, this is a picture of that symbolically depicts exploration, right? And when exploration was one of the main agendas of human space exploration, this was the typical crew composition: white men from the military. And that changed over time, and now crews, this is a NASA image, look like that. But what did really change? People expected a lot of change by having different crew compositions, adequately representing humanity in there. But nothing much changed because they were all humans. And the question is, what will happen if we take this one step further and take the distinction between robotic exploration and human exploration that is represented in this image by Carl Sagan and the Viking lander, to introduce robots into human missions? This is the this is a new NASA robot that is supposed to replace human astronauts on the International Space Station. And that would be one approach, having humanoid robots be humans instead of humans. Well, this is a robot that is a companion robot for humans. Simon, it's called. And here it is with Alexander Gerst on the International Space Station. They're having a conversation, and it's meant to help humans cope with outer space. And this is what I'm interested in, and this is what I'm proposing as an experiment for the MPOL mission, just to make sure that what you see in this image now, if you see it, does not happen. So we are going to take this robot. It's a NOW robot provided by my university. We're actually not going to take one of them. We're going to take two of them to the astronaut center, to the analog training center in Poland, and we're going to have them there as part of the crew. And the advantage of that robot is that it looks like a human. It can behave like a human, but it can also behave like that little companion robot we just saw. And my idea of research is taking this very, very cute little person, guy, thing, and integrating it as part of a human crew, and then asking the questions, asking questions about human interaction with the robot. So as a theologian, I'm interested in the human nature of the robot and how humans interact with the robot as a human. So what properties do you ascribe to a robot? Is it your pal? Can you give tasks to the robot? Can it help you? Do you have to care for the robot, or do you repair it? That would be an interesting question, for instance. And how do you perceive the robot? Is this your buddy? Is it something that helps you deal with isolation with a crew under these special circumstances? So what we are going to do when we are in Poland, we're going to go there with our two robot friends, companions, and see what comes out of it. And one of the advantages of that robot is that it has such a load of sensors that we can, let's try to put it that way, automatically accumulate all the data we would need to properly analyze that. And with that, I'll say thank you for listening, and I'll close my talk. Thanks.
Thank you very much. I actually have one question for you. Do you think that most of your research, oh yeah, please come back here. Yeah. Do we fit? Yes. I'm a little bit outside. Can you go a little bit more to the left? Yes. I think it's perfect. Yeah, there is some delay. Yes, but it's perfect like this. Do you think most of your research really needs to be conducted in space? Because most of your questions are actually more main questions for interaction with robots, right?
You see, the thing about that is there is a lot of research already being done on that, right? So we have this little seal-like puppet that you give into homes for the elderly, and they can interact with that. And it's a robot. It's not a, oh, sorry, yeah, thank you. It's a robot. It's not an actual seal. It's not a living being, but they play with it as if it were a companion. So we have that. And the question is, why did NASA send that robot to the International Space Station? And I think the situation out there or in isolation is a very specific one that is different from, say, having a robot that cares for elderly people or for demented people. So yeah, we can do part of that, but part of that needs to be done in isolation, because only then does the robot become part of the crew and not a friend, right? Maybe I phrased that wrong when I gave the speech. Thank you for the question.
Yeah, thank you very much.
Okay, for now, we are going to proceed with our for the rest of our program. So next up is our student from the TU Delft. His name is Kevin Robbesom, and he is doing research on solar cells. So please go ahead.
Good afternoon, everybody. Thank you. Yeah, I study at the TU Delft. I study mechanical engineering and physics. And my research on solar cells is mainly going to be on the inside production of solar cells. Inside of the Moon and Mars, there are few natural resources, but there are enough to build actual solar cells. And my research is going to test in several steps how we as analog astronauts or as real astronauts can build and make solar cells from all the materials that we can find at the location. And this will start with me going to the MPOL mission with my previous speaker and with Agatha. And there I will take already finished small solar cells and I will construct them in arrays, see if that's all working, put them on the actual basis, see if I can generate power, if that all works. And according to that, I'm gonna take every step backwards until I get to the step where I get to filter and harvest all the precious materials out of the ground and soil from the Mars ground or Moon ground, and use that to build up the entire solar cells. This for me will be a very exciting mission and an exciting part of being part of this step into the future. And aside from that, I'm also working on a platform for not just me as a analog astronaut, but for all the analog astronauts who have spoken, all the moon bases and corporations who organize and plan these missions. This platform will be called Extra, the Extra-terrestrial analog research platform, and it'll be used to organize and make everybody come together on one platform, all the data, all the papers, and all the missions, that we have one big view of what kind of research are being done and what the next steps are to be to go on for the next missions, next future in space exploration. So for all the analog astronauts listening, when it launches, feel free to come to see what's going on inside of Moon and Mars and all the other locations. And aside from that, I'll be happy to present my research once it's finished. Thank you.
Thank you very much. Thank you. Our next speaker is space science and physics teacher Roxane Perrier, and she teaches at IPSA in Toulouse. So please, Roxane, go ahead.
Hello, everyone. Can you hear me? Okay. No one?
We hear you.
We can hear you.
We
Okay.
can hear you.
Can you see my slides? Okay. So, hello, everyone. We are also, so as we were presented, we are from Toulouse at the IPSA Aeronautical and Space Engineering School. And we are only young collaborators because we are only for a couple of months in this beautiful adventure that's Moon Mars, thanks to the professor Bernard Foing. You have to know that our school is mainly, of course, working under the disciplines of science, technology, engineering, and mathematics. And of course, we want our students to work as a project-based learning. So we are doing everything possible for them to work as a project team ever since starting with the beginning of their school course. So our story starts in June 2020 when Professor Bernard Foing accepted to come as a jury for our presentation of big projects. Big projects at IPSA means projects that our students will choose at the beginning of their academic year, and they will be working on it for an entire year, maybe 2, or even 3 for a couple of our students that will talk just after me. You will see that they are getting involved even for a 3rd year in their project that they are very keen to move forward with. So the type of project that we are proposing to our students is, for example, the blog. You will have the blog address here on the slide. Of course, it's in French for now, but starting with this year, the pilot is an English teacher, so it will be bilingual. Articles are about space engineering, but also airplanes and aeronautical engineering, because our students want to be either space engineers, either aeronautical engineers. We have a big project about a telescope in collaboration with an association. Our students will try to are constructing a telescope, and they will pilot it from Toulouse, as the telescope will be installed in French Polynesia. We talked about airplanes, wind tunnel, and digital experiments are developed as a big project for those who are passionate about it, and for space engineers too, because you have to know, in order to get to space, you need to pass through the air. Space experiments are my big project. It's my big project. We are proposing experiments from space that can be validated either in zero-G flights, because our French space agency, CNES, is proposing to the students to validate some experience. So every year we will apply for this contest, and we cross fingers to be chosen for the next zero-G flight for us to test our experiments. But not only knowing that in space we are sending all our satellites and instruments as telescopes, all the space data is coming back to Earth and needs to be treated and interpreted. So there's a big project about space data and what can we do with it. Along with this, you have to know that Professor Foing gave us the possibility to get into the adventure as soon as he met us, because ever since, so 1 week after he met us, one of our students, Tom, joined the scouting mission that Charlotte and Mark presented earlier for a week. So he was very proud to represent our school and very, very happy to be part of this adventure. At IPSA, we started to organize for an EuroMoon Mars IPSA coordination group. So I'm being part of the coordination group, and I have 2 students. Every time you see an year after the IPSA letters, that's when our students will become engineers. So Sonia Pavi will become an engineer in 2023, as Mathieu Lafon, who's coordinating from Korea, because he's a 4th year student and he's remotely with us for all this summer. So Mathieu will become an engineer in 2022. We developed and we joined the EMM EuroMoon Mars team with 3 for now subgroups. IPSA Habitat, who wants to conceive and design our version of what will be an habitat on the Moon or Mars. We are the IPSA, also EMM Poland. You will see the entire team just after me of students, 6 students that will join, as I will be. I will do. From 15 to 30 October, the Ample mission with Agatha, Kevin, and Michael. And of course, IPSA Communication, a short group for now, 2 students, and our communication manager, who will manage all the communication around this collaboration between IPSA and EuroMoon Mars. You have to know that thanks to this adventure, we have the opportunity to participate to the Galaxy Forum. So I'll be talking, as Sabrina told you earlier, for the Forum Galaxy about the how to prepare space engineers and women for the moon. But also with one of my students, I will participate to the EuroMoon Mars Habitat workshop on the 19th of September. The future events, we will have an event in Toulouse, 25th and 26th September, where we'll have the honor to welcome Bernard Foing, who will meet our students and who will join us for the workshop, Habitat workshop. And of course, the Ample mission that we're very keen to participate to. And this Ample mission will allow us to develop a couple of experiments. One of the experiments will be about high pH water, like you know that neutral water is at 7 pH, and at a pH, a neutral pH of 7. We will drink high pH water at 9.4, and we will see what's the impact on the human body. I'll let now the floor to my students, who will explain to you what they will do during this Ample mission. So here's to you, Theo and Quentin.
So hello everyone, my name is Theo Borowski. I'm 20 years old and I'm a student at IPSA Toulouse in the 3rd year. So as far as I can remember, I've been passionate about space and I've already worked on a few projects related to it. For instance, I will be part of the EuroMoon Mars Poland campaign as an analog astronaut. I also work on a lunar-based project this summer with Quentin, and I also work with Quentin on the AMI project since 2 years already, that we will present just after.
Yeah, exactly. So my name is Quentin Gou, I'm 20 years old. I'm a 3-year student at EPSA in Toulouse. So I can barely remember the first time I looked up the sky and said to myself, wow, I want to be part of space exploration. So now it's the dream become a reality. So as a summer project with EMM and with my friends of EPSA, we're starting to develop an habitat, a lunar habitat on the moon. And then I've been chosen with my friend Theo and the others as analog astronauts for the EMM Poland in October. So now let's talk about our journey. Thank you. So we started our journey 2 years ago with my friend Theo and the invaluable help of Roxana Perrier. So we started to create an autonomous robot capable to assist astronauts during EVA by carrying a payload. So this payload can have many nature. It can be a toolbox, spare parts, a robot. But the other interesting point is that this robot can be turned into a nanosatellite launcher, for example. So this last year, we wanted to create 2 technical demonstrators to see if every technology we used worked and if every security norms were respected. So we created 2 demonstrators in 2 different environments, into water and into zero-G plane. So all the data we can have, all the data you can have with it will give us double technical tests, visibility and credibility.
This project is really important for us because it gave us the first knowledge of how to manage such a big project. During this summer, so we work on an EuroMoon Mars project, which consists on creating and thinking a whole lunar base. So the first research that we did were about the moon surface temperatures, and they seem to be really binary, such as we can see on those pictures. So temperature dissipate quickly after the moon's terminator pass by, and that's why on those type of projects, you really need to think about how you're going to deal with the lack and the excess of heat in the station. So we thought that was a pretty interesting subject with Quentin, and we decided to create and to work on a thermal regulation device during our mission in Poland. So to end our small speech, here you can see some prototypes of EuroMoon Mars Poland mission badges. Hello everyone, my name is Emma and I'm 21 years old. I will be an analog astronaut on the EMM4 mission in about a month. I am currently doing my 4th year at IPSA, which is an engineering school in France, and I will be specializing next year in aerospace technologies, rockets and satellites. But I'm also very interested in astronomy and telescopes, so that's why during the EMM4 mission, I will be remotely controlling a telescope to take pictures of landing sites of the Chang'e 3 missions on the moon.
So, hello everyone. I am Hugo Castin. I'm 21. I will try to be as quick as possible. I'm in my 4th year at IPSA. I specialized in mechatronics. I'm related to MM because I worked on a project. Please go back. I worked on Aurora. This is a project of a vertical hydroponic farm. To be fast, hydroponic is a new way to cultivate plants. You don't have soil, you just spray water with nutrients on the roots of the plants. So during EMPL, I will be analog astronaut and work at the Mission Control Center. And I will work on now aquaponic protocols and experiment on COVID-19 social distancing. So thank you, everyone. I will give it to Julien.
Hi everyone, my name is Julien. I'm also 21 years old and IPSA student in 4th year. I will be specialized in the mechatronics, and I'm linked with MPOL by Aurora, which also was a part. I was interested in the power source, and I discovered, thanks to the work of NASA, the Advanced Stirling radioisotope generator, which is basically simply a Stirling generator which uses the heat spread by plutonium-237. So during EMPOL, I will study the impact of pandemic on a crew, and more specifically inside a very confined and small area. Thank you for listening to me.
Hello everyone, I hope you can hear me. My name is Michael Kahn and I'm 19 years old. I'm currently an engineer student at IPSA, which is specialized in aeronautic. I submitted my participation to the campaign during the holiday, and I will be participate in the mission, in the Poland mission. So I will be in the first crew named EMM1, where I will be an astronaut analog. During this campaign, I created a project named Now What. So Now What, it's for not a waste of time. Currently, one of the big obstacles for future mission in space is waste management. That's why my project will try to reduce the waste quantities and to reuse these wastes. So my experiment is composed of 2 stages. The first stage will be to check some quick-worn equipment, like packages, and substitute these with compostable equipment. This equipment will be useful in order to create a plantation in the close or far future on Mars or on the Moon. That's why during the campaign, I will analyze the compost samples. The objective is to create a compost rich in nutrients. The second stage is to imagine a new shape for quick-worn object that is not compostable, such as conserves. This equipment will be assembled to produce part of a useful object. I will take the example of a conserve, which can be reimaged and assembled in order to form a leg stable for a laboratory, for example. This research will be done on CATIA, where we can modelize objects. And the final aim of my experience is to reduce the mass on board the rocket and to reconsider the waste, which can be really useful. That's why I think this is not a waste of time. Thank you for having me.
Applause for you. I would like to give a great thanks to all the speakers for this Euromoon Mars program. And to conclude this part of the program for today and introduce the next part, I would like to introduce Bernard again. Go ahead.
Okay, thank you. So it was a great session from this spaceship Leiden Observatory. And what you have seen is that what we do is not only it's about science, data, it's about technology, it's about going to live on the moon and Mars with analog, going in the field, and also is to bridging with society. And so this shows also we had contributors from many places of the world, from here, from this spaceship, but also from Hawaii, from France, Paris, Toulouse, from various places. It really shows that we are all part of Spaceship Earth. But as Spaceship Earth, when we are going to move beyond to our 8th continent, the moon, what are we going to bring out of Spaceship Earth? So for this is what we'll discuss a bit in the next session, which is Art Moon Mars TV. And I'm happy to invite here as the presenters, the curators of the MoonGallery Closed Cosmos, but they are also very active in our Art Moon Mars platform. And we'll have also a talk at 5 o'clock where we discuss about the history of Art Moon Mars with many of you, but they are going now to run this session on Art Moon Mars and MoonGallery with a number of Moon Mars artists that have joined us on the spaceship and also outside. So my pleasure, please come. So you come this way up, and I go in the back. And I leave you the floor.
Hello, everyone. We are honored to welcome you on the 3rd day of Ars Electronica, the festival for art, technology, and society here at the Old Leiden Observatory. Today, we are joining the global journey, mapping the new world together with our MoonGallery artists.
It's been almost 50 years since art was last placed on the moon, and we believe that it is time to go back. It would be a real challenge to select one particular artwork to send as a seed of future culture, start shaping the moon culture. But luckily, we don't have to.
That's why we create a series of open calls for the international community to collect the best ideas, poetic phenomena, and artifacts to become a part of the MoonGallery.
MoonGallery, here you can see a prototype of the MoonGallery, is an international collaborative artwork and a gallery of ideas worth sending to the moon. It has this compact format of 10 by 10 centimeter grid, which will be mounted to exterior paneling of a lunar lander, and it will be sent to the moon in as early as 2022. It will bring 100 compact artifacts to the moon in this petri dish-like gallery, which will start shaping the future culture on the moon.
So we ask our participants to think big, but small. Every artwork has to be just 1 cubic centimeter.
If you think about it, 1 cubic centimeter is a compact, efficient format for space travel, and is just big enough to investigate with the naked eye, just about the size that we see the moon when we look at the sky from Earth.
Well, at the moment, the human presence beyond Earth planet is still a matter of survival. But how can we make this desert-like place habitable? How we can turn moon into this poetic place we are dreaming of at the nightfall with a glass of wine?
We suggest bringing this collection of seeds of the MoonGallery because we believe that art and culture make the distinction between mere survival and life.
Sending a gallery of art to the moon is a symbolic gesture, which has a real influence, a way to reboot culture, and to rethink our values for better living on Earth planet.
So now we want to use this chance to ask you, what would you like to send to the moon? What are the ideas that you want to promote into the future, and what are the ideas that you want to leave behind? We look forward to seeing your proposals at the moongallery.eu website.
And now, to whet a bit your imagination and to prove that it's actually possible to fit plenty into 1 cubic centimeter, we would like to invite our MoonGallery artists to share their ideas with you.
Ronald Fless has many passions and professions. He is a lawyer, watercolor painter, musician. Looking upon our planet from space represents for him a strong symbol of a united humankind, which you will see from his proposal. Ronald, the floor is yours.
Thank you. Thank you. Hi, I'm Ronald Fless. Here you see the little, it's the real size, I think. It's gonna get on the moon lander. It's gonna be left on the moon. And then here you see a little red heart, and that is, of course, a highly symbolic value, but that is that is symbolizing my project. My project has a big poster, which you can't see here, but it's consisting of my artworks, and that are basically religious and highly old places of old civilizations and peoples. There's a lot on Earth of those, and I think it's important if we have this little cubic centimeter piece of symbolic art on the moon, and it looks upon our Earth, that we would say symbolize the friendship, being, you know, not the division between the peoples. These times there's a lot of people and governments and whatever that try and divide people. I think we should unite them. So this is my project that's based on the old historic idea of a blood brother ritual. Now, you in these COVID times, we're not really thinking about getting any blood out and so, because we are all anyway very sensitive about contagion and so on. But it's a symbolic way of expressing friendship. So you can do it by elbow, by the foot, in a little curtsy or whatever. But it's about expressing friendship, specifically with the old peoples, representatives of old peoples and of the main religions that we have on Earth. And for other reasons, I do travel a lot around the world before COVID and hopefully afterwards. So my program is a bit disturbed by this Corona affair. But for instance, I met with the Maoris, which are very old people, of course, and we had a ceremony, and I've done a domine, a Dutch Protestant minister, for the same thing, and we tried to put it in a context. And I still have a whole lot of agenda to go to Greenland for the Inuits, which has been arranged depending on COVID. We might go there in November, and we go on, and then we do these ceremonies. We make a nice movie as well that we can show on the exhibitions that are all over the world with the MoonGallery. And that's in short my project. Thank you.
Thank you, Ronald, very much. Now I'm gonna introduce the next artist. Did you ever heard of the things called PDOCs? I learned about them from the submission of Mina Phillips. For the MoonGallery collection, Mina created a 1 cubic centimeter cube with a hole in the shape of cone cut it into it. This hole represents the home of PDOCs, little mollusks which carve their homes in the rock. So this is a symbol of creation of these little insects left into the history as a memory. So let's listen to Mina's explanation of her proposal.
Hi, my name is Mina, and I'm here to talk about my work called Memory. Memory is a solid wooden cube with a hole cut into the middle of it that is cone-shaped. This cone shape. Hi, my name is Mina, and I'm here to talk about my work called Memory. Memory is a solid wooden cube with a hole cut into the middle of it that is cone-shaped. This cone shape is a metaphor for a pickaxe hole. They bore holes into these rocks, into the rocks in the oceans, and they live their entire lives in these tiny homes that they've made for themselves. What I find very interesting about a pickaxe home is the process by which they make it. It is a circular, continuous churning, not linear, and you can see the process, and you can also see the development of a pitax from a tiny little creature to a bigger creature, hence the cone shape. And once they leave their homes or die, they leave these holes behind as traces of their existence, which is what I hope to capture in the piece called Memory. What is even more enlightening to me about a pitax home, it is very humble. It also, well, I was struck by the fact that it lives its entire life in this tiny little space, and also stricken by the fact that it only really took what it absolutely needed. One of my favorite quotes is by Gaston Bachelard from his book called The Poetics of Space, where he says, one must live to build one's house and not build one's house to live in. It is an important lesson for humanity as we move forward to explore new habitats beyond our own planet. And it is a chance for us to do things a bit differently than we are used to use sustainable resources, and if we must leave traces of our own existence, let it be as the humble pitax does. I wish I could have been there in person to see the work in the Moon Garden exhibit. I am humbled and honored to be part of this show, and I hope you enjoy my work.
Can you imagine how crystallized water molecules would swarm in space, and how would that look like? Me neither, until Isabella Dosoglu made her proposal to the MoonGallery. Isabella is a multidisciplinary scientist, artist, and musician, and today she will tell us more about the importance of her special molecules in space.
Hello, hi, thank you. My name is Isabella, and I made a piece for the MoonGallery, and in fact, I'm also a member of EMM core group and worked with an internship with Bernard looking at molecules in space, although my specialization is in bioinformatics, and I am a computer scientist. Although I also spent 4 years of my life being a professional musician. Until then, I translated into my master's, in which I learned a lot of things with regards to science, and in particular, molecular science in our body. So we study genetic sequences, we study structural bioinformatics, so the structure of the proteins that do things in our cells. So the structure of these molecules have a function in our body. So when it came to submitting a piece for the MoonGallery, you're given this cube. So I thought, okay, what can I put into this cube? And we also studied a little bit of molecular dynamic simulations, where we model molecules with water to study their stability and the interactions and so on. So the molecule that I chose to put into this crystal, or the crystallized molecule that I chose to put into the cube, was ATP synthase, otherwise known as complex B, that is responsible for making energy in the cell. And this is a rotary motor-like molecule that, in fact, is another way that we can perceive ourselves. For example, who we are as molecular-powered machines. Also, if we are simulated in vacuo, so in a square, due to our limitation in computation complexity, but also we can interpret this as we are suspended in space in vacuo or in isolation. So this piece is meant to firstly introduce some ideas in science that maybe is not readily available to the public, but also to give the public a chance to interpret it as they will. And also to encapsulate a lot of criticism towards where we are in science and our limitations to acquire molecular data, and also the implications of being molecular machines in space where we are affected with radiation and so on. So, and lastly, who we are as the interpreter as we struggle with acquiring information of atomic structures. Who we as observers? What does the observer play a role when you're in space? And how can we protect our molecules in our bodies from space radiation? So as you can see, it's a lot of stuff. And I'm really happy to be a part of this and an advocate for multidisciplinary science and art. So I encourage you to come up with something, anything, whatever your background is, and submit it to MoonGallery. Thank you.
Thank you, Isabella, for such an inspiring presentation. I think we all learned so much about the molecules in our body. And the next artist of the MoonGallery is Gabriela LaRussa. He's a designer who likes to work with things and emotions, and he will tell us about what kind of symbolic connection he would like to create between Earth and the Moon.
Hello, my name is Gabriele LaRussa. I'm a designer from Italy, and I'm here in this rainy day from my improvised workspace to talk a bit about the project for the MoonGallery. My project called The Two Marbles, and the idea behind the project was to ensure the psychological well-being of future settlements on the Moon in this case, or in any case in any other long-time space mission, by creating something that could keep the connection between the Mother Earth, or the humans on Earth, and humans living outside of Earth. It also has the double function of, by keeping the connection, to avoid a sense of detachment between these two different groups of humans, to avoid a sense of creating a us and them situation. To achieve so, I created these two small glass marbles, one representing the Earth and has the likeness of Earth to be kept on the Moon, and vice versa, another one having the resemblance of the Moon to be kept on Earth. The idea speaks to the power of totem, of having something physical to represent something that it's hard to grasp. In this case, it's not necessarily a spiritual concept, but it's also the idea of something that's so far away, like the Moon, that sometimes it's, even in this century, it's for us very hard to grasp as something that we can go on, we can land on, something that exists and that we can reach. And consequently, it might be as hard to imagine that people could live on the surface of the Moon. And so again, these two small totems, they might even have more power if made with materials coming from Earth and from the Moon. And that's one of the reasons why I chose glass as a material, because it's one of the few materials, certain types of glass are one of the few materials that can be created with the lunar soil. And also because the first full photo of the Earth is called the blue marble, so it's a good way of tying them together. But again, the very focus of the project is is about this sense of keeping humans together, keeping them as a one, even when in the future we'll be able to travel long distances and move to other planets or other satellites like the moon. And in the exhibition you will find also an upscaled version of the model, which is a spin on the project. The idea remained the same of creating like a totemic figure, but in this case it's a scavenged version of the totem, I would say. Imagine as something that someone on a space settlement could create with material found around, and that's why it's made from hardware components from a computer. But again, it's in its final representation, when you will see it, it's a future primitive artifacts, because it's something that it speaks about just the idea of creating something symbolic that could connect the person creating it to an idea or in this case a group of people. Obviously this project lives in a very optimistic future when we see ourselves as just one group of humans rather than divided in country or ethnicity. So obviously we are still far from that kind of vision of ourselves, but I think one of the next challenges for us, when we will possibly overcome the challenges of feeling ourselves as one population, will be the ones of keep that same feeling when we will be able to even go out from that planet. I just want to close very quickly saying thank you to Jochen Holz, which is the creator, the glass artist that created the two small marbles that you can see in the exhibition, and by hoping that everyone is safe at the moment and that the protests that are going on both sides, on both figurative side of the planet, will have a positive changing effect on our future. And thank you for listening, and goodbye.
Do you know when the first woman will set the foot on the moon? Maybe earlier than you can imagine, at least in the symbolic form of the beautiful artifact created by artist and photographer Dana Lamonda. Let's welcome her here to figure out how would she fit the whole essence of woman in just 1 cubic centimeter. Dana, the floor is yours.
Hi, I'm Dana. Well, what do you want to leave behind? What was that? At first I wanted chocolates. I wanted to bring the ocean. And then I decided I want to do a female because she makes babies and because the female body takes care of life on Earth. But of course, the next challenge was, how am I going to get a female body into a tiny, teeny little cube? So I was thinking. It took a few months before I figured it out, but this is what I did. I put a picture in a laser. The laser cuts it up. This is the way the ashes become stardust. And stardust is an essential link in creation. So that's what I did. A female body to the Earth in a little cube. Thank you.
Thank you, Dana, for this beautiful story. Now I would like to introduce to you a Singaporean artist, Lakshmi Mohan Babu. She likes to incorporate cross-cultural elements and philosophies in her work. I could try to explain to you the philosophy behind her MoonGallery project, but maybe it is better to watch a beautiful animation she created about her piece and about how this artifact is going to travel to the moon.
Eduardo Katz is so far the only artist from the gallery who already has an artwork exhibited in space. Not on the moon yet, but we're working on that, but it is on the International Space Station. It is my pleasure to introduce you, Eduardo Katz, talking to you from Chicago.
Hi, I'm Eduardo Katz, and I'd like to talk to you today about my artwork Ad Sum. Ad Sum was created specifically for the MoonGallery project in 2019. And it's a Latin word that means I am here, in the sense that, say, an instructor would call out your name and you would say present. So you signal your presence at the location that you find yourself, and you seek to express that presence. So Ad Sum is a poem, is a space poem that I created based on an alphabet, a typeface that I developed that is fully symmetrical. And it is composed of two words. One is nos, and the other one, read in the other direction, is soon. Nos addresses consciousness, addresses the fact that humans will be present on the moon moving forward into the next decades and the next centuries with the Moon Village and other projects. And we will start then to bring consciousness, human consciousness, to the moon on a permanent manner. And this will have tremendous impact. This will originate new cultural habits. And of course, art and poetry go where human culture goes. And soon is an expression, of course, of this vision of this future that will begin very soon, but also it's a temporal reference, right? So this piece is conceived for the MoonGallery, meaning that it measures 1 by 1 by 1 centimeter, and it can be read in any direction. It is a laser etched optical glass poem sculptural object that I'm going to show to you now, as you can see here. Basically, the letter S can be seen in every direction. It's symmetrical. And then, as we can see here, the letter N also works in any direction. The letter S in the work is basically the infinite symbol. And the letter N is the hourglass. One makes reference to cosmic time, which is infinity, and the other makes reference to the human scale. The two letters O, one is bigger than the other. So that signals the moon orbiting the Earth, but the shift in scale from small to big is a zoom out, and the big to small is a zoom in. So we can zoom out from human temporal scale to cosmic scale, and zoom back in from cosmic scale to human temporal scale. So that is, in a nutshell, Ad Sum. Thank you.
The next artist of the MoonGallery is Guy Livingston. He is a pianist and a producer based in The Hague, but he performs all over the world. The challenge of creating an artwork which would have a significance hundreds or even thousands of years from now made him thinking of many dark thoughts, which led him to a very dramatic and beautiful poetic piece, which he will introduce. Guy, the floor is yours.
Thank you. I want to start with a poem. There is so much loneliness in that gold.
the moon of every night is not the moon that Adam saw. The centuries of human wakefulness have left it brimming with ancient tears. Look at it. It is your mirror. So that's a poem by Borges that inspired me. I guess as so many people have come up with kind of optimistic artworks, and I'm a little embarrassed how pessimistic mine is. Mine is definitely dark, but I don't think it's too dark. What I did was, inspired by that poem, is that I wrote my own poem, a poem which was just a piece of paper on which I wrote a spiral in pencil of all the dark thoughts, all the dark things that the moon has seen over the last centuries. Everything that's happened on Earth, wars, rapes, murders, politics, everything that plagues, everything that plagues our lives and has plagued it, and that the moon has seen and that the moon has reflected. And I wrote all those down on this big circle of paper, and I burnt it, and I put the ashes in the cube. Thank you.
Thank you, Guy, for your beautiful poem and presentation. And I want to introduce you to the next speaker, Nick Vershore. Strategic interventions and visual statements on violence and threat of violence are the main objectives of project by Nick Vershore. Even though the word violence appears often in his work, in fact, Nick is really concerned about the peace on the Earth and beyond our planet. That's why the title of his submission is Last Bullet. Nick, the floor is yours.
Thank you. My name is Nick Vershore. I will read you my statement on the contribution for this MoonGallery, which is the last bullet. The project I'm going to tell you about could or could not be fake news, or could not be false hope, or could not be impossible to reach. But at least it could be a small step for a man to just think about the silence of the guns. And it could be a giant leap for mankind just to consider the possibility of end of warfare. So my contribution to the MoonGallery is the last bullet. The last bullet is a monument. Last bullet is a small yet essential monument founded in commemoration of all the known and unknown victims of violence all over our globe. In placing this last bullet on the face of the moon as a token of faith and hope, we inhabitants of the planet strongly empathize the intention not to export our acts of violence to other planets or into the universe. The time has come that we people living on this wee blue dot in space should have the courage to send the last bullet up to the moon as an horrifying monument, an awkward remembrance, and of the never ever shoot each other again. In a way, this really sounds like a solid and hopeful blueprint for the future, but I have some doubts. So, despite all honest intentions of my fellow creatures, the last bullet is accompanied by a guardian, a supervisor to monitor the process. It's the artist's watchful eye, a deep inside the bullet, a watchful eye to keep checking the fragile balance between good and evil. In this proposal, if this proposal doesn't work, our journey into space could turn out to be a bloody warfare of all against all, as Thomas Hobbes wrote it in 1642. It could turn out to become an awakening Leviathan or a runaway train that cannot be stopped. So, my friends, space invaders, let's watch our moves and take care of the future we are facing. Try to achieve the highest goal possible and ask for the best you could ever hope for. Today is the time to finally shoot the moon. Thank you.
Thank you so much for this inspiring speech. Now I would like to thank all MoonGallery artists for their great ideas, definitely worth sending to the moon, and introduce the next speaker. She's a new collaborator of the Art Moon Mars platform and MoonGallery. Paulina Almeida, she is a choreographer of the Tomorrow Walk of the Astronauts, which will happen through the Botanical Garden, and you can join us tomorrow to see it yourself. Paulina, the floor is yours.
Hello. So the Walk Dude, or the Walk Me to the Moon, was inspired by the MoonGallery work and this dream about going to the moon and the possibility of realizing it already on the water, okay, and already realize it on the earth. So from out of these different elements that are the possible way of walking, the possible building of costumes and the new skins and the imagination of each one that could participate on this walk. This was invented in Portugal when the MoonGallery was visiting us this year. And it came back to this space. It was came from this sort of like how possible it is to also start to collect and start to live already the dream of going to the moon, and what thoughts can come out of this realization. And the project itself was built by a lot of participants, international participants in Portugal, in the context of residents. And the costumes were built each one by one by the own imagination of the people that were invited to create them with artistic view. And then from that, the movements that have a lot of input from Bernard's tales and stories about what it is to live on the moon and how possible it is. So everything becomes a kind of reality in a very short term. So the imagination of each participant that is invited to just dress this and feel how these artifacts can work over their skin, and how they can invent a new story each place they go and with what they find, and then how this can open up the imagination for future. So this is the idea of the moonwalk.
Thank you very much. With this final talk, I would like to thank all contributors and all artists and everyone who gave a presentation today. We are going to have a very short break. We will be back with you at 5 o'clock, and then Bernard Voing is going to give a Sci-art presentation. And after that, we will inaugurate our very new exhibition. So the MoonGallery, the Closed Cosmos exhibition we have here today. So for now, we take a short break, and we hope to see you back at 5 o'clock. Thank you. Welcome back, everyone, to the Ars Electronica third day. We are still working on our program of today. Today's main theme is astronomy and art. And we are actually now going to start with the third part of our program, the inauguration of the new exhibition Closed Cosmos. And to celebrate this and introduce this, I would like to invite Bernard Voing to give a presentation on science, art and science. So please, Bernard, take the floor.
Okay, thank you very much, Sana. So it's my pleasure to come back to give this lecture on Art Moon Mars. So Art Moon Mars is a platform that we have developed in the last 10 years to bridge between artists, scientists, engineers, and in particular on the cultural artistic activities. And you see there are a number of co-authors in this program in the last 10 years that have really worked with us. And so, I go here. Space there. Maybe I ask you to put the slide. Yeah. So the next. Yeah. So you can see artists. We have artists and designers and innovators. So so we started actually with a Moon. Yes. With a Moon Academy workshop, an event we organized in 2010, where together with Alicia Framis, quite a famous artist, we created a community and Moon Academy, where we had a session at ESTEC, but also we had some activities in Amsterdam. So we had artists, designers coming to ESTEC, working on different topics like moon-based design, but also what would be a fashion on the moon. And even they opened a shop on the moon. They started a business where they produce objects that we could sell on the surface of the moon. And we opened a shop in the middle of Amsterdam that was running for more than 3 months, where you could see objects that we were able to purchase on the surface of the moon. So eventually they came to our moon base, the moon surface. You can see here the lander that we are using for this exhibition, the so-called Extra-terrestrial lander, and you see the group on the surface of Mars. So already at that time, we had some residency. An artist proposed the idea of a lunar Zen garden. This is an artwork you could do on the moon after you land the first rover. The first rover could start to put some traces on the surface of the moon and have already a mineral artwork, so-called Zen garden. And actually, this artist spent a few months in residence together with me and our robotic group, and she used some of our rover on our moon yard to show that it was indeed feasible. And we would like to borrow future rovers that are left quiet by scientists and engineers, and during some of their free time, we could draw this lunar Zen garden. So here is some of these artists and designers meeting at ESTEC. You see, at ESTEC we have this Columbus module, and this is quite a general program when we have friends and artists that want to get involved into space. We bring them to ESTEC. So we have many of you that have already been coming there, and I hope that in the public we will have also some of you when the COVID situation will allow more. Actually, we have also open day. Every year we organize an open day, and we had like 9,000, 10,000 participants in the previous year. This year we will also organize an open day, but due to the pandemics, we are going to limit it only to people with limited mobility, handicapped people. So we do a special program for them. And so we will restrict it to about 400 visitors for this time. But we hope that next year we'll be able to already to greet 1,000 of you there. But here you see how the artists are presented with some of our activities, but also we put them outside this Columbus laboratory that is a mock-up of what we have on the International Space Station. So we also made a workshop. Here some of these mixed artists, scientists, engineers, they are working on the design of a moon base, where to put the base. So they have to take some maps, and we have some architects that are trying to inform what is feasible and what type of construction material is feasible. Then after these activities, this led to the participation actually to the Sonic Act festival. That's a festival that is happening in Amsterdam, you must know. And the theme of this festival was Dark Universe. So they asked me to advise them of what is the meaning of dark universe for the astrophysicists. So I talked them about the dark universe, dark matter, dark energy, and so on. And I gave them some input. And then you had hundreds of artists that were more or less inspired by this vision of dark universe, because for artists, actually, dark means something completely different than for astrophysicists. They are talking about the dark part of the mind and all the dark side of our personalities. But it was a very interesting also confrontation between artists and scientists and space engineers. And after this, we got in contact with Evelina Dominic and Dmitry Gelfand, and we opened a class of art science and space at the Royal Academy of Fine Arts, KABK, in The Hague. And we organized a 3-month program where part-time some of the student artists could develop art inspired by space. So this was the first theme of the first year. The second year, we had a program with artwork inspired by the Moon and Mars. And then they prepared artwork, some of them collective, some of them individual. And I'm going to show you just an example of this artwork. For instance, for those of you that like planets, and in particular, the artists simulated the atmosphere of the giant planet. And they created a big ball of glass where they put a special fluid, and then they could, in fact, simulate the hydrodynamics of this fluid in the atmosphere of a giant planet, like we have on Jupiter, Saturn, or also Uranus and Neptune. But this is also now relevant to some thousands of giant planets, which are now detected around other stars. Now we had also one artwork. It's called Lunar Freedom. And it's in fact an installation with a robotic dome that is describing a moon base. And you can see this moon base with a dome so that the astronauts can breathe. And there are also robotic system, and it was a beautiful light installation, rotating, so it was rotating base. And he wanted, if you can see that on the top of the dome, you can see the dome, there is a hole because the whole dome was hit by a meteorite. And then all the humans have disappeared from this moon base, but the robotic base continues to operate because it's powered with solar light. Now we brought this artwork to the International Lunar Meeting, where we had some of the pioneer Russian scientists that have been working on the lunar program and also Apollo astronaut program. And when they saw this piece of art, they reacted very violently. Say, no, we cannot let this happen. We are going to fix the dome, and then we'll put back some human in it. So that, and this artist, it was called Ronald, actually, and he was, I invited him to some planetary congress, European Planetary Congress. We went into Portugal, and he could bring his work there and discuss it with the scientists. And then you could see also that the vocabulary, the culture between scientists and artists, we need to really find more common ground. So a good way is to make them meet with each other, make presentation, and also go for nice dinners and drinks together in the evening of this congress. So we had this art, science, and space program for 3 years consecutive with Evelina Dominic and Dmitry Gelfand and Edwin van der Heijden, and we had every year like 20 students there. Some other example of artists. This is Marit Miklep. She's a Scandinavian artist that wants to fly a slime mold to the moon. Actually, I have myself on a previous experiment flown slime mold, but only to orbital, to the International Space Station, and we found that this is surviving super well, this slime mold. And actually, also, it's what is fascinating, the property of this slime mold to propagate and to go to places to feed itself. And for this, they have to solve a very clever optimization algorithm that is quite complex to reproduce with a computer. So sometimes they can solve a question that I cannot solve with my computer. But now we have smart scientists, they do AI. I think they are able to imitate what slime mold are doing. And so that's a slime mold, and we are planning to put a slime mold on the surface of the moon. Now, we have also done some experiment later, how you could use some organism like this, mixed with lunar soil. You could create a kind of a rigid structure. You could really make the soil more rigid, and you could use that for construction. So you could have a little wall, and then you would feed it with bacteria, cyanobacteria, slime mold, and then you would make much more robust for future habitation. So as a follow-up of this collaboration with the Royal Academy of Art, we also were in contact with a colleague from Free University, that's Raoul Fraser, which is an expert in photosynthesis and biomaterial. And we created a collaboration looking at the symbiotic machine. So machines which are a mixture of robot and life that you could develop on Earth, but you could even send to the Moon and Mars. And so we worked on a various projects. And for instance, we grew some organic tissue, and we used them. Kombucha, for example, kombucha, you can drink it, you can eat it, but also you can make textile out of it. So after this, we had another year with the Royal Academy of Fine Arts, with also some 20 students, and Frédéric de Wilde, this is a Belgian artist, also quite well known in our community. And we had a special activity called Space is a Place. After this, also thanks to the collaboration with Raoul Fraser on symbiotic machine, we had the pleasure to meet Nick Verschoor, that you have seen earlier. And we started a 3-year program where he was able to inspire with us some students for 3 themes. First year was, we are in Netherlands, so we had a kind of monarchic theme for the first year, King of the Moon. Second year, King of Mars. And just this January, we did the last edition just before pandemic called Next Suburb, the Moon. And for this program, here you can see a view of the Academy of Applied Art of Willem de Kooning, a beautiful place where they are mastering, developing, studying a lot of various techniques. You have textile, you have media, you have printing, you have video, you have all possible with the applied art techniques. And it was great to visit them. They are very hands-on, but also they think with their hand, and they really act with their brain. So it's a great academy. So here are some views of the visit from the Willem de Kooning Applied Academy. So they come here. You see them in the so-called Erasmus iBase. That's where we store some of the human spaceflight artifacts. Actually, behind the visitors, you can see a capsule, which is called Photon. It's a capsule that we can launch space, very similar to the capsule that brought Gagarin in space in 1961. And so it's pressurized inside, so an astronaut can survive inside for a few orbits. We have reused it several times to launch experiments either in pressurized environments inside for a duration of 3 weeks, or even we put some experiment outside the capsule to test how living organisms or materials or even artifacts could survive in deep space. So here we see that this is young artists. We even put them in zero gravity. This is inside the Columbus module. You see they were very inspired and they start to float there. And they get also their imagination to work to see what art and also what would be their life in space. Also, we try to organize that they meet scientists and engineers, so they discuss the different topics around the table. Here, for instance, this was a project about generating energy from the surface of the moon, but other aspects. And so we have this practice of organizing the so-called Euro-Moon-Mars workshop, 2 per year, where we host between 50 and 100 visitors, collaborators at ESTEC. And so we have done it until, it was last December. And we had planned one in March, so we had to postpone. And then we replaced this session of the Euro-Mars team in presence. So you see, this is pre-pandemic time. We don't have distancing here, and we had also hands-on activities where we could work with telescopes. We could work with a lander. You can see also a botanist there that was growing some plants out of lunar soil analog. So we are testing how to grow this plant. And this you recognize is Agata Kolodziejczyk, that has built this moon base that we are going to visit in the second half of October. We have also Matt Aranilchuk, so he's an analog astronaut. And so we have really a large range of countries and disciplines there. Also, for instance, this is an interesting example of, it was a virtual reality project, but that was developed by an artist from Quebec. So this art super geek, in the sense that I gave him some images from the moon and from the Apollo time, and from this he was able to generate a 3D landscape where you could walk with virtual reality, but also he developed a tool where you could assemble some elements and build your own habitat with this. And here you can see Maria Grulich is a young space engineer testing this system. Now we brought also this type of experience in for the public. So this is an event that was organized in the frame of the 2 Days Art Festival. You know, I think the largest electronic art festival in the Netherlands every year in September in the Holland area. And so we had actually started a collaboration where we participated to some of their events in the Söderstrand theater before construction. Here, this is in the middle of The Hague, just in front of the town hall. We invaded a movie theater and we organized a Human Mars workshop there and some simulation with VR. Here you can see a VR and a traverse on the surface of the moon. Also, eventually, and that's bridges to what we do here in the Leiden Observatory. We organize events for the public. And actually, we brought a number of telescopes. This is a beautiful one. And from the Spui, from really the center of Amsterdam, we showed the stars, we showed the planet. Actually, already 20 years ago, in the frame of an Earth-Moon Relationship Conference that we had organized in Padova. You know Padova, the city of Galileo, and it's one of the oldest university with Leiden, maybe. Yeah, Padova, Leiden maybe is the oldest, but in Italy, I think Padova is one of the oldest with Bologna in Italy, but they had Galileo, okay? And you can see the chair of Galileo, and also you can see some of the books of Galileo. So we had a great workshop there, and we invited artists, we invited psychologists, okay, to talk about what is the role of the moon on humans, theologian, and we had a group of young art scientists that said, "Oh, we want to invent a lunar sociological telescope." What is that? It's a little telescope you bring in your pocket, something like that. I think, yeah, Anna, you have one. Huh? You have brought you one from China, I think, and you have always your telescope with you. And in the middle of the night in the street, you show it, or you have a bigger telescope like this one, or that you put in front of a discotheque. And when people are queuing for the discotheque, you show them the moon, and then they are really completely impressed. They say, "Wow, they have never seen the moon through a telescope." You know, even better after they have gone through the discotheque, and they are one of the music. It's not really always my type. But if you're in good company, I think discotheque is fine. But when you want to escape the noise from the discotheque, you go outside. And then you put your eye to a telescope, watch the moon, and you have this cosmic vision of that we are really on this spaceship Earth. sometimes it's a kind of a similar feeling of what you experience during a solar eclipse. Solar eclipse, you see this alignment between the sun, the moon, Earth, and you also on the line. And so this is this type of a moment where you see the cosmic dimension of human and the spiritual dimension of the universe. Because in this case, as we have learned, I mean, we are among the first in the last, let's say, 100 years that have the possibility to develop instruments to look so far back in the universe, to look at how the universe was born with a Big Bang, look how the chemical elements were formed. So you see the water from our body. So hydrogen comes from the Big Bang, the oxygen comes from the core of stars, and then you have dust. So you have all these processes, and they have created ingredients that were delivered to Earth. Eventually, they led to life. And now we have a life that is able to observe itself in its past. And so sometimes just by putting this telescope and observing a very close object, people can realize their connection. And also I wish, and that's a project I think we share with the astronomy community, that we could find ways also to switch off all the city lights and sometimes to look at the Milky Way. I know a place where we can see the Milky Way very close to here, so that's something we could try to share in the future. So here another example of observing from the sky. And eventually, also in this today's art festival, I like music, I have to say. My first profession was to teach music. Well, my first money I did was to teach music. And then, I didn't make much. And then I had to teach math and realized I could do much more by teaching math. And then I became a physicist, astrophysicist. But I tried to continue to play in orchestra. And during various parts of my career, I was continuing music in conservatory, but then I was in Chile for 3 years at the European Southern Observatory. And there I had a super chance. I met some brilliant musicians from the conservatory of the city of La Serena, which is close to the observatory. And they are brilliant. And they accepted me as a viola, and we created a quartet there. And you know the name we gave to this quartet? Something that bridge Europe and South America, that bridge the North and the South. We call it Cuarteto Mistral. Mistral is the name of a poet from France, but there is also a poetess from Chile, Gabriela Mistral, a Nobel Prize. And she was born in a little village close to La Serena. And so we say, a wind that blows from north to south, like in the south of France. Two poets, we have to call our quartet Mistral. So, and actually we had so much fun. And we created this quartet Mistral. So it's with a mixture of artists, and some of them we played all over South America with them. And so then every time in my work, I was trying to find colleagues also with whom I could share some of this passion of music. And luckily at ESTEC, we have some good colleagues, and you will hear them later. And we call ourselves ESTEC Space Strings. And also at ESTEC, we have a number of musical bands, so where you have engineers and scientists playing. And today we'll have also some guests with us that is going to join. Ronald is going to join us in our quartet. But eventually for this art festival, we had these workshops about Moon and Mars, and then we put some agora, so some chair elements in the center of the egg. And during the day, we would do debate with the public. Oh, do we need to go to space? What can we discover there? In the evening, wow, we put a piano there, and we could play to the stars with the space strings, with our concert pianist, Maria Prokofieva, and also with our jazz band. We have also ESTEC for Jazzy, a band at ESTEC that plays in such event. And you may have seen Nika Terra. She's the lead singer for this ESTEC band. She has been participating to some of the opening of our event in the MoonGallery garden in Amstel Park. And we hope that we will have the possibility to organize a singing event in the future, but now because of restriction, we have to limit the singing. So that's, and eventually we even had astronauts that landed in the middle of the egg. So together with our lander and some of these astronaut candidates, you can recognize here Agata from Poland and Angeliki from Greece, Matt also from is a pilot from Poland. We are going to meet them in October. They landed there, and we put a telescope on the also on the lander. So yeah, we love also to bring telescope everywhere. Do you know where this is taking place? This is in front of the Concertgebouw in Amsterdam. So there was a big event, and actually Amanda was with us, even with her daughter Lupe, and we installed our lander on the park in front of the Concertgebouw. And it was an international event organized all over the world, I think in collaboration also with IAU. It's called On the Moon Again. And there were people observing the moon all over the world. And we say, okay, we want to do that as well. And we went to Concertgebouw. And at the same time, there was a film movie concert about Star Wars. Then you had people already dressed up for the occasion. And we just brought the telescope and we showed them the moon in a sense. So another interesting project that we conducted with Savannah Olosorai. So she is a student in archiving. So she was studying how to archive books in the library and so on. And she wanted to, then she worked with me on the project of what do we put in an Alexandria library to preserve the heritage of humankind. And I had proposed an idea also together with our colleague Jim Burke from the International Space University that we could store it on the moon, because there it could last for millions of years. We could bury it, and then we could save this heritage, but also we could save even some of the technology that we have on Earth. So in case the civilization disappears on Earth, we could also develop a system to retransmit back this information in a very simple form, maybe just radio telecommunication, that a very primitive civilization would be able to rebuild in a faster time if everything had disappeared. But so the technical project, we worked with Jim Burke, but the content of this library, Savannah made a special work on you know, what type of content, what countries, what discipline, and what do we want to send. So what do we see as our true heritage, and how do we decide, how do we preserve, and so on. Actually, Savannah has been working then at the Nordic Space Expo. So she has really made this transition from being an archivist to space. So this happens a lot to some of our young Moon Mars students and others when they see that they can contribute to space efforts they come. Now, I would like to also to touch on another big project, and this is developed in collaboration with IAU, GHOU, so Global Hands-on Universe. And so it's a group that is organizing special activities for teachers and related to the universe. And they started a series of global science opera. So that is a show, a TV show that is developed by a community from 10 to 20 classes all over the world. And then there is a theme every year, and each of these class is asked to act for one of these themes. And so first, 1 year in 2016, there was a collaboration with CERN, and then they made a show about ghost particles. And in 2017, they had heard me in a talk about the Moon Village. So they approached me and said, oh, let's do a global science opera about the Moon Village. So they visited me at ESTEC, and they asked me, what do you think is the future? So I told them, yes, so in 2030, we'll have a moon base. 2040, we will have 100 people on the moon, and the first baby will be born on the moon. And then we will have a city on the moon. We'll have the Republic of the Moon in 2060. And then I was starting to elaborate very far, and then they stop and say, oh, baby on the moon. That's a good theme for a global science opera. And then they picked this topic, the first baby on the moon. So what type of school do we send them when they're on the moon? What do we teach them? And then we worked all this aspect with with high school kids, and all over the world, 20 countries. And so each country had to propose one school to do it. And actually, so in ESTEC, we were collaborating with the ideas, but also we hosted one of the schools. Interesting experience, because actually it was a school of refugees, kids from very far in the Netherlands, the logistic to bring them. And they came and they arrived at ESTEC. Some of them didn't have a passport. Okay, but we found a special organization, also with the help of Space Expo and also with support our security personnel. And they could organize their event, filming their scene at Space Expo and at ESTEC, and also contributing live to this TV broadcast on Global Science Opera. So here's some illustration of the story. Oh yes, so 25 countries actually, 2-minute scene, and it was broadcast on TV. And actually here, for this Ars Electronica and Leiden Observatory and MoonGallery event, we have been invited to provide also a scene for the Global Science Opera of this year. And the theme of this year is about energy. And so we plan to have some of our astronauts discovering, okay, that you really need energy and how you can collect energy when you're in space. And so we will film this scene in the botanical garden, and also we have filmed some part of it. So this is the Global Science Opera Moon Village. So they are the cast of characters. Luke, Gravity was also a character. Gravity is a tough character. It's not a good character if you're on the moon and you have to return on Earth. The gravity is too high. So the Sonia, which was the main character, didn't know if she could go back to Earth because she was born on the moon. And she was trying to find a solution. So she has some colleagues, and there was a nice robot that played a key role. I don't want to spoil the story, but played a key role to help her to fix this problem with gravity. So as you see, Global Science Opera, we are connected with all areas of art. Also, we have a good tradition of having music in our events. So for instance, we had some musicians from the orchestra, the Rotterdam Orchestra, and also from the Hague Orchestra, some professional, beautiful, that came to our event. We even organized an event where we mix the music with one artist. So that's Alexandra Arshanskaya, that was in real time painting digitally, inspired by this music. And you see another important part of our collaboration is what you see in the lower right. We have a special place at ESTEC where we call Escape, with a terrace. And we also celebrate socially, we drink and we discuss. Many of new projects were born there. So we need to find now a replacement for ESTEC Escape. Possibly the terrace outside the observatory here could be a good place, or even this spaceship inside the Leiden Observatory. Then here are some views of also other visits of artists and professionals. The same artists played a concert inside of our Erasmus IB gallery. So now I would like to end with bridging towards the Moon Art Gallery. What is the story of it? So that's something that you could trace back even to this 2005 opportunity where we launched a kind of art gallery in space. And that's a piece of art and science. You see, actually each of these samples is a special molecules. And because of the size of the molecules, it absorbs the light in a different wavelength range. And all these are aromatic molecules. Also, we have found, as you have heard the talk from Isabella this morning, we have found a buckyball in space. So we put also some buckyball on orbit and see how they survive. So these are big survivors molecules that survive in space. We put them, and this is on a tray that was left for 3 weeks in space. So you can see that. It was launched twice, 2002, 2005, we various sample, but also we had organic, we had lichen, life form, and we checked what survived. We put tardigrade as well, this little organism that just dry out and go in space. And when you put them back on Earth in the water, they are happy as they were. And this is how we recover the capsule. And on the right part, you see a little box. This is so-called biopan. This is the size of a pan where you put the sample inside, you launch it to space, and then you open the box to UV. And then before you come back, you close the box, and you try to come back on one side, which is burned, and the part where the experiment should not be burned. And this is what happened. But so we have also experiments where you put a rock and you put some biological organism in it, and you put it on the burning side and check whether this rock with life, this would survive the re-entry in the atmosphere. So we flew that 3 weeks on the photon. Actually, we flew it twice. First time we flew it but the rocket exploded after 30 seconds. So yeah, didn't get much result. But this was our first art gallery attempt, obviously. But 2005, this worked well, and we got the data. And after this, we flew again this type of experiment on bigger tray to the International Space Station, where we left it for 1 year and a half. So you can see here the various samples from the outer terrace of the International Space Station. And so this we covered the sample, and we could see that some organic molecules are very big survivors, but we found some lichens, we put some seeds, we put some tardigrade, we put various organisms, and we got the idea, so after this, we should really try to put also these various samples to the surface of the moon, living organism and so on. But also, we thought that we should open this opportunity to the community at large, and also invite art scientists, artists to also be part of this adventure. So that's okay. This how you could have an idea to have a MoonGallery for art, science, and science. And okay, oh look, this is a little commercial for the event for today. This is a photo of the gallery that we inaugurated at Amstel Park. So with the configuration of, and it's simple. We want to put an experiment on the moon, and I've worked on building a moon lander there. And if you want really to launch a mission to the moon, it costs you about 100 million euros. And so typically, as a payload, they ask you 1 million euros per kilo. So we are going, I hope our TV show will be very successful, and we are able to raise money so we can raise some of this amount. But another way to go through, as I was explained, that we want to miniaturize, and so we want to bring the first art museum, and in a very miniaturized version, so this will be only 100 grams, and then we try to negotiate to have a much lower price to go there. And this is what you could put in a 10 by 10 centimeter, some of this miniature artifact. And now you will see for the first time an exhibition of some of the artifact, real size, with a very nice display at the end of this Leiden Observatory MoonGallery spaceship. So we had a number of events. I don't know if you are covering this, but I'm covering just the very early phase. And then we had Anna and Lisa really taking charge of the both the Art Moon Mars initiative, but also the MoonGallery pilot project. So this was in the early phase. We had some codes. So this is just illustration of some of the artwork that have been submitted, developed for some of the first events. We had an event at Space Expo, at ESTEC, at Prague. This is okay, one about outer space treaty, for instance. And you will see some of this piece. One of the artists, I don't know if you show this piece. One of the artists was an astrophysicist that spent 1 year in Antarctica. And so he proposed to send the purest air of Earth back to the moon. So he collected this air in Antarctica and put it in a flask. And then you have other creation, a dark cube, and a beautiful also allegory of Earth, and with a kind of mirror. I call it the Escher mirror, which I would like to put on the moon and put a little camera there and make a selfie of the camera with the Earth in the background. That's one of our dreams. Then we have some other art piece. We have a monument to the intellect from Anastasia Izotova. We had the beautiful pieces that show the lunar phase. Also this Renato piece, which has a very interesting story we can tell you at the dinner tonight. And eventually, we start to put this gallery all over the world. So we organize events, but also field work, where we start to deploy it in extreme environment that look like the Moon and Mars. So here we put it, as you have seen, on the top of the glacier in Switzerland, and we had this lander, but you can recognize the MoonGallery there installed. Then we had a campaign in Hawaii, and with a nice collaboration between the astronauts there that were doing their theoretical work, we even placed the version of the MoonGallery of Hawaii. That was this was the deployment by Priyanka, or by Priyanka, who is also a MoonGallery artist. And you can see actually, I'm not sure this is Hawaii. Maybe this is the moon actually, because it really looks like the moon, huh? Except that on the moon the sky is black because there is no atmosphere. Everything is dark. We have also a version of this with the dark sky. And then we had this beautiful expedition in Iceland that have been reported. And here again, they went to the glacier, but they didn't forget to bring also a MoonGallery on the glacier. So this is a mock-up. More recently, are you talking about Amstel Park? But we have had a little event in Amstel Park where we opened an event. We invited some Apollo astronauts. We put our lander there, and you have some views. And so it was the first exhibition after lockdown. And I think that I want also to thank you to allow us to have our second event after lockdown, and with very special measures that we are following, good distancing and a good protection. So eventually, yes, we had some events there, and we did even some footage of music. I think this has been edited by Isabella, our film editor-in-chief. And so I would like to end with a little teaser about an event that we organized in Aveiro for the Water Festival in July. Also, just by doing special conditions, it's a festival that attracts, I think, 10,000 visitors per year. But here we had to confine it, and we had this moonwalk show that was prepared with Paulina, and you can see some of these astronauts walking in the city of Aveiro. And tomorrow we will see them in Leiden. Now, actually, they came one day earlier. And so we have close to Estek, a place which is a gigantic spaceship, beautiful place. It's called Decos. It's a company that is a paper-free office company. And the owner is in love with space. So on the garden, he has installed a Moon-Mars yard where we can test our drone, our rovers. And also yesterday, we are our astronauts. They could evolve there. And we had also a TV team, national TV team that was there for another interview. We could get them to film that. So you can see some of these astronauts, they are deploying a system on the moon, and they are trying to find a solution to their energy problem. And so eventually we have them here. And soon after, we went into Space Expo, and we can see some of these artists. They were visiting Space Expo. We had a special agreement, and they went there even to the point that they could look at a real moonstone from Apollo time. So you see some of these they even look at the first rocket that went on the moon. As you know, this is the first rocket that landed on the moon in the 50s. Developed by Hergé, Tintin. I don't in Dutch, how do you say that? But this is. And so we have also a large group worldwide where we try to communicate and also develop cultural activities that are inspired by space. It's called Itacus Committee. And we organize actually a big session as part of the Astronautic Congress in Bremen in 2018. And you can see some of the members that you can recognize from your own Mars and Itacus teams. There we have all ages, we have a large diversity. So actually, this is my last slide. And now I would like, because we have mentioned that it's also very much into music. I would like to invite the members of the STEC space string or the space strings and friends to go on stage, and we are going to illustrate to you to have some of the space strings playing for us. Please come in. So may I introduce you? So Gaetano Galusso is an aerospace engineer working on navigation. Thomas Berger is also an engineer, and he has worked on navigation, but now he works on Earth observation. And we have Ronald Fless. He is a very good friend of MoonGallery, and also he's a MoonGallery artist. He's a lawyer, and he has many activities all worldwide, and a great musician. He's playing viola, close to the cello, yes, and they are going to play for us as a conclusion for this talk about Art Moon Mars, but also as a little musical event to introduce the next phase, which should be the opening of the MoonGallery Closed Cosmos exhibition as part of the Ars Electronica Festival, the Leiden Observatory contribution. And we want really here to thank very much our host. So Sana, Pedro, we want to thank your team. We want to thank the Leiden University, Leiden Observatory for this great event, spaceship, but also all the support you have given. We want also to thank all the Euro Mars, Art Moon Mars teams, the artists that were here. We want to thank you, all our public from Earth and beyond that are following the show, hopefully. And now I think that we are going to move towards music. At the same time, you can appreciate the special area where we are, as Sana has introduced. This in this visitor center, they have installed an exhibition inspired by the Drake equation, and they've been doing a number of event activities, talks, and there's a beautiful set of pictures here that are very inspiring for us. So it's great to have a spaceship with so beautiful art inside. So maybe that should inspire my colleagues that are designing the spaceship traveling to the moon to get also some beautiful illustration on it. And this spaceship will have really good visual content, good company, as we are be able to enjoy, and also music. So let's have music. And as we say in music, back to Bach. And actually now I say, even with, like people say back to the moon, actually I'm transforming that. I change it into forward to Bach. Because Bach is really not only the past, it's really in our heart towards the future. And we go also forward to the moon. Thank you very much for your attention. So maybe I've done this before. Now I promise we are playing the world here. Because there's a version from a quartet from Schubert we have recently discovered for this occasion, and we played in a formation with quartet, but with two viola. Because there is Ronald and Nina viola. And so we are playing but and so it's a quartet from Schubert. It's a posthumous work, so it has no number. But so it's a late piece. Okay, so this was the space trip and MoonGallery collaboration. I think it's a pleasure to give the floor to our curator, so Anna and Lisa, that are going to open formally the MoonGallery plus Cosmos exhibition. Oh, yes. The floor is yours.
Thank you.
Thank you. It's a very beautiful opening moment.
This time, so we want to really thank our host, the Observatory, this MoonGallery spaceship. This time, MoonGallery has the honor to exhibit its collection at the Leiden University Observatory, which is the oldest still operating observatory in the world. It was founded in 1633. This historical monument still plays an important role in the life of Leiden city and the university. And the observatory is designed for research and development of the capacity of perception of our universe. Like the observatory, the artists of the MoonGallery, they aim to raise perception by asking fundamental questions about life, questions close to ourselves and the cosmos we inhabit.
So the title of the exhibition is Closed Cosmos. Closed Cosmos is a collective installation which looks close at ourselves and into the distant space. As a beings, we stand between of the microscope and the telescope, in between of the cell and the galaxy, under and above. These notions of extremes, they're fundamental for our understanding of the questions about our past and about our future.
Closed Cosmos features 36 micro-artifacts that represent universal values and human aspirations that are envisioned and materialized by the MoonGallery artists.
So the exhibition will be open from tomorrow and every weekend until the end of the December. And you are really welcome to visit, but we understand that at the moment, not every of you can make it to Leiden. So we make a small preview of the MoonGallery Closed Cosmos exhibition, especially for you right now. Enjoy!
So, thank you very much. I hope you can see me now, or we have to still. Yeah, thank you so much. So, this has been an amazing day, and I think the diverse program that we showed you today is actually proof of that the collaboration and partnership of science and art is an absolute must and addition for society. I think we can learn so much from each other, and we can just not even learn from each other, but even create new and amazing things. So that's actually what we really love to do at our old observatory. Show you innovative things, show you new things where art and science come together. And I think the MoonGallery Closed Cosmos exhibition is a great addition to our current exhibition. So as Elisaveta and Anna has told you before, from tomorrow on, you can visit us again, and we are very looking forward to welcome you here. Yeah, and actually tomorrow also, to again celebrate as if we haven't done enough yet, we would like to invite you to our astronauts in moon suits at 2 o'clock, and they will walk along the botanical garden and also in the city center of Leiden. And after that, I think we can happily look back to this 4 days event of Ars Electronica Festival. Thank you for today. Thank you for tuning in, and we hope to see you tomorrow here in Leiden. Thank you. Thank you all.